Hi everyone, welcome to this new tutorial. Today we will be building a fighting game in TypeScript using TypeScript and the Kaboom.js library. So I've already made this game in the past and it was in JavaScript and I've made a tutorial on my channel on it. And I thought that just to use TypeScript I would revisit older games I've made and just do them in TypeScript. So it would be like a series where I would make the first tutorial in JavaScript and then later on in the future could do a tutorial on TypeScript on the same game that I've built. That way I could revisit some architectural decisions, and also really like improve the code on how I implement stuff, because I've learned a lot of since the tutorial in JavaScript that I've made about this game. Now this game, just to give credit where it's due, it's made the original idea for this fighting game using the following assets you see was by Chris Courses, another YouTuber who makes tutorials in vanilla JavaScript. So he made the same game in vanilla JavaScript a year ago, I think. And then I made the same thing, but using the Kaboom.js library. So if you don't know, Kaboom.js is a very easy to use library for making games. It saves a lot of time, and that I made this tutorial just to show you like the difference, because I think the original tutorial that Chris Courses made was like three hours, and the game that I've built using my tutorial, building the game with Kaboom.js instead of just plain vanilla JavaScript with the Canvas API, was 1 hour. So just to give you can see how much time is saved as an estimate. Now here, the difference is that it's going to be TypeScript. So just before we start, we dive into the project, I just want to say that if you are not familiar with my channel or are not familiar with TypeScript, this tutorial is still made with beginner in mind. So if you don't know Kaboom.js, the library, no worries. I'll explain everything as I go along. Same thing for TypeScript. I will explain how TypeScript works and how to get your dev setup, etc. When working with TypeScript instead of like JavaScript, it's not as easy for the setup. So first of all, let's showcase the actual game, and then we'll jump right into the setup section. So let's first start by playing it. So as you can see, I can attack. Now I'm alone. It's a multiplayer game, so you use the WASD keys for the first player, the samurai, and the arrow keys for the ninja. And here you can see that I can attack with both. I can jump, attack here. And now because I'm playing with my left hand and my right hand for both characters, it's a bit hard for me to simulate what a fight with someone else would look like. But just to show you, you can see that at the top corner, at the top of the screen, you have a health bar that updates as the players are hit. And now just to show you what happens when the player dies, you have a winner loser text that follows the player. I thought it was a nice addition. Now, if you have watched my previous tutorial in JavaScript, vanilla JavaScript using the Kaboom.js library, you may have noticed that there are like a key differences. The first one is that there is no timer in this version of the game. And I thought that from a design perspective, there wasn't really a need for it. You just end the game when either one of the player has died. So that was my thought process. So I decided to just remove it. And also the other thing is that maybe the map is different, because it uses the same assets, but the way the tiles are placed, etc., is different. And because for this tutorial, instead of drawing the map through code, so by importing the assets and then placing them through code, we're going to use a software called Tiled that is going to be used to create the layout and the spawn points of our various entities, so the player 1, player 2, etc. So I'm going to show you how to use Tiled for that. Now this was something that wasn't previously known how to do in Kaboom.js. You would usually make levels either by writing through code the positions of the various sprites and tiles, or you would simply use the add level function offered by Kaboom, which would take a array of strings to define your level layout. Both of these aren't that ideal, so really having an external editor that you can just like drag and drop and paint is really nice. And I'm going to show you, hopefully in this tutorial, how to deal with that. So that's basically the game, and let's jump right into it. So I'm going to open my editor, and then we'll just start with the setup. All right, so I have an empty folder. Just before we continue, I'm using VS Code. I recommend that you follow along and also use VS Code. Now, if you're more advanced, feel free to use whatever editor you want. But if you're more of a beginner, it would be best if you would just follow the instructions so that you don't get lost. Now, as opposed to vanilla JavaScript, where I could import the library using a script tag, with TypeScript, things are different. And we're going to use NPM. So that means the Node ecosystem. So you need to have Node.js installed on your computer. So Node.js is a runtime environment for your computer. So it runs JavaScript code outside of the browser. So like on your computer, your operating system instead of through the browser. And what is good, I guess, advantageous with Node.js is that you have access to NPM, which is a package registry where you can install packages, so libraries, by typing a command. If you're familiar with, for example, Python, where you do pip install the name of the library, well, it's the same thing with NPM. So here, we're going to need, so I'm going to assume that you have Node.js installed. If you don't know how to install Node.js, a quick Google search will tell you. It's a known problem, I guess. There are many guides, videos online on how to do that, so I'm not going to cover this aspect. So that's that. So I'm assuming now that you have Node.js installed, and if you have Node.js installed, you should, by doing node version, node dash dash version, have the version of Node.js appear if Node is indeed correctly installed. If it isn't showing, that means you have done something wrong, and then you have to figure this out using other videos or the internet, basically. Now, assuming you have Node.js installed all well, what I want you to do to set up our project is to run npm create vite at latest dot. I'm going to explain the command. So what does this do? It's going to, using the npm create, we're going to initiate a vite project. What is vite? Vite is I guess the simplest way to put it is it's a bundler. It bundles your code into code that can be executed by your browser. So I'm pretty sure maybe you're not that familiar with the ecosystem, the web dev ecosystem, but TypeScript is a language that needs to be like compiled or transpiled to JavaScript. And then once it is compiled to JavaScript, it can run. But there is also a difference is in that JavaScript in Node.js is not exactly the same as JavaScript in the browser, and you need to make sure your JavaScript in Node.js is converted into a JavaScript that can be read by your browser. So usually bundlers in the past, I don't know if it's still the case, but in the past, the JavaScript that you would write using those tools with npm, etc., was a more recent version that wasn't supported by all browsers. So you would have to like compile using a bundler into a JavaScript, a vanilla JavaScript that can be run in the browser. So that's my understanding. I hope I was clear with my explanations. There is a bunch of like information also online on how, why, and how those bundlers works. And usually one of the advantages of bundlers is that they will really like not only compile your JavaScript or TypeScript code into JavaScript that can be run in the browser, but they will also make sure to like really compress it so that everything is neatly compact into one file, so one.js file at the end. So basically your output, what you're going to actually, for example, put on itch.io, is a zip file that contains an HTML file, maybe some CSS, a CSS file then, and a single JavaScript file that contains all of your JavaScript that has been compiled and minified and compressed so that it takes the least amount of bandwidth or space. So I think bandwidth might not be the correct term for this, but anyway, so instead of like having multiple files of various kilobytes, you have a single file that is like really optimized, compressed, and that's why people use bundlers as well. All right, so now here npm create vite at latest. Maybe I should increase the font size of the editor just so you maybe that's too much. All right, this should be enough. So here you have npm create, so that's specific to, usually you would do npm install for packages, but for templates, for boilerplate like that, it's usually an npm create and then the tool, vite being the bundler, it's not a library. And then at latest, it takes the latest version of vite, and dot here means that I want to create this template, set up my project within the actual folder we're currently in, which is fighting-ts. You can name this however you'd like, it doesn't matter. I think maybe there are some naming conventions you have to respect, but let's try it out and see. It should normally work. So I'm gonna press enter, and you'll have a bunch of choice to make. So what is going to be the name of your project? It's called the package name. I'm just gonna keep it fighting-ts. It usually takes your folder name and then just lowercases it, sorry. And then it's going to tell you to select a framework. And here, we're not going to use React, Vue, Preact, Lit, Svelte, or any of those. We're just going to use vanilla. And vanilla what? Vanilla TypeScript. So after having selected both of these, now what you're going to do is simply run npm install. So the way it works is that you have this package.json file that keeps track of all of your dependencies and the specific versions of them. So that way, if I want my code to run the exact same way on someone else's computer and they have installed their setup, for example, it's an open source project and I want contributors, then they would clone the project into their local machine. And then because of this package.json, when they hit npm install, it's going to install all the packages they need with the correct version for everyone. So I'm going to just hit npm install. It's going to install a bunch of stuff. And then once this is done, a package-lock.json should appear, which contains all your modules, etc. And also you'll have a node underscore modules, which is where the actual code for the libraries is stored. Usually this .get ignore file will ignore this when you commit, because this can be pretty large, and when you're going to commit your changes, it's going to be like too many changes. So that's why it's included here by default. I think it's here. Yeah. So yeah, don't touch any of that. You don't have to. And now what we're going to do is I'm just going to delete everything. Literally everything in the source folder. We're going to keep the source folder itself though, because we're going to write our code in it. As for the public folder is where we're going to host our store our assets. So what I'm going to do here, I'm going to delete, of course, this, we can keep it actually, because we're going to use it as a favicon. It doesn't matter, but you can keep it if you want. So I'm going to, inside the public folder, create an assets folder. This is where we're going to keep all of our assets. So the sprites, etc. And we're going to also create another folder here, and I'm going to call it maps. And this, there's only going to be one map, but in case in the future we want to extend this game, I thought that I would try to organize the code in such a way that it could be more easily extensible. So the maps folder, what this does? Well, here we're going to store the .json file of our maps. So Tiled, the software here that you can download by everything, the assets, the links to download Tiled, assets, Tiled, and I think that's basically it. And the source code for this project will hopefully be in the description below of this tutorial. So here, Tiled, what it does is you draw your map, and then when you hit on export as, you can export as a .json file, which is going to be the format we're going to need, because we're going to then import, basically fetch this JSON file in our code and draw the map by looking at the data that is in that file. So yeah, Now, before moving on, let's actually create two other folders. In our assets folder, we are going to have a first folder that is going to be called background. What this will contain is basically the images for the background in our game. And there's like two layers that we're going to need. And at the same level, we're going to need an entities folder. Did I put it correctly, or did I? Oh, whoops. Wait, did I create the folder? I'm not sure. Okay, it created it within. This is not what we want. We want to actually create the entities here. Entities folder. Now I need to just delete, move to the, oh yeah, all right. So this folder is going to contain the sprites for our samurai and ninja players. And finally, yep, that's it. The rest of the assets, they don't need to be organized logically for now. We could have a third folder that would be basically tile sets, or props, I guess. But yeah, you feel free to do whatever you want, but maybe not, because when I'm going to import later on the files, the assets, I'm going to use paths that follows the structure that I currently have. And if you have a different one, you might not realize, if you're following the tutorial, that why certain assets are not loading. All right, so I'm going to basically drag and drop the assets that I need. So for the background here, you will be able to find those assets in the description. Links towards where to download them is going to be hopefully mentioned. And yep, so, and the entities folder, we're gonna also have two sprite sheets. By the way, just want to say that for those two sprite sheets, the way I acquired them was that I took the original sprite sheet that is available on itch.io, and I used a website called Free Sprite Packer, which allows you to take multiple images and just combine them into a single sprite sheet. And this is one of the improvements I've made for this tutorial compared to the previous one, where it was in vanilla JavaScript using the Kaboom.js library, is that it was multiple images. So for example, this line was separate, and in terms of how to like swap animation, etc., it resulted in tedious code. So that's why I decided to just combine them into single sprite sheets, etc. So that it would make our lives easier. All right, so here the assets are there. Now the last three assets are just going to be dropped into the public folder. So the fence, the oakwood tile set, this is important for our tiled map. So we're going to draw using that tile set. The shop animation, and that's it. So now in the source folder, we're ready to start working. So I'm going to create a main.ts file. Main.ts. It's empty for now, but in the index, okay, all right, it's already here, so everything is fine. So here in main.ts, we're going to start, I think, yeah, let's start by importing the assets we need. So yeah, so far it's relatively just like JavaScript. So let's first import the backgrounds, and then we will do something else with it. So the first statement you need is to, of course, import the Kaboom.js library. Without that, there is nothing you can do. So we're going to import Kaboom. Oh, I forgot to install Kaboom. So one thing I completely forgot to do is that. So we have our project structure set up by Vite, but now we also need to install the Kaboom.js library. To do so, you just do in the terminal npm install Kaboom, and it should install it for you. Once this is done, you should not have any error. It will tell you that it added one package. And then here I'm going to do import Kaboom from Kaboom. And that's it. Kaboom was imported, and Oh, actually, I just realized this is not what we want. The way we're going to structure our code is to have a single instance of Kaboom, so a single canvas. And to do that, a pattern that I've adopted is to create a Kaboom context.ts file. I think I called it this way originally. Yep, maybe instead of context, just to have a shorter thing. So CTX instead, Kaboom CTX. And then here, we're going to import Kaboom from Kaboom. And then this is where we're going to define our single instance of Kaboom. And we're going to pass that instance around in our various file that need to draw things on the screen or use Kaboom functions so that everything there's a single source of truth. That way it's going to be much more convenient. So now what I'm going to do is in the Kaboom CTX file, I'm going to first do a const k. This is the constant we're going to export so that other files in our project, TypeScript project, will be able to use the Kaboom.js related functions. And here, the way you initiate a canvas is by calling the Kaboom function and passing in, it's not required, but we're going to pass in an object within and specify a bunch of options. One of them is, for example, which width you want. And this is where we specify the resolution. So height, width. So I'm going to go with a 1280 by 720. And then I'm going to set the letterbox option to true. This option is very important. What it does, it's going to allow your canvas to be responsive. So regardless of the screen size of your window, it's going to make sure that the aspect ratio is respected. And then finally, we're going to have two things. So we're going to have the global property being set to false. That means we cannot use Kaboom outside of this K object. We cannot call any functions, any Kaboom functions from outside. This is important to set if we want to have a clean code base. I haven't done this earlier on. I would use simply the global version of Kaboom. But if you have watched my previous tutorial, you might have noticed that by doing this, you might have some cases where there is conflicts between functions that comes from Kaboom and functions that come from vanilla JavaScript, for example. And that would, for example, there's only one example I can think of. But as you work with, for example, more libraries together, that might become an issue. That's why I think this approach is better. And then finally, the last one, which is not mandatory because by default, the debug mode is activated. So debug mode, what is it in Kaboom.js? It's basically a way for you to see all of your hitboxes by pressing the F1 key when you run your game. Now, here I've set it to true, but the reason I'm doing this is just so I don't forget to set it back to false. Because when you release your game, you actually want to put it false so that players cannot access the debug menu by clicking on the F1 key. So just to look more professional. So once this is done, I'm going to export default. So it's the only thing basically we're exporting from this file, K. And now in Kaboom CTX, in main.ts. Oh, I wrote the code in the wrong place. So yeah, copy that code, put it in the Kaboom.ctx, which is basically the Kaboom context, and then remove everything from main.ts. All right, so once this is done, in main.ts, let's start by first importing the context. So import K from Kaboom CTX. Now here, one of the advantages of using, well, it's not an advantage, but one difference compared to using vanilla JavaScript modules without a bundler is that you would have to specify .js every time. But here you can just leave it as is. You don't have to do it. So that's a difference. You don't have to worry about it. All right, so once we have this, let's first import our assets, and then we'll create our scene. And then, you know what? I think it's better to just create the scene and then add the assets as we need them. So to create our scenes, you use the scene function. So that's every time I do k dot, that means I'm going to use a Kaboom related function. Here, the scene function in Kaboom.js allows you to create a scene. It takes two params. The first param is the name of the scene, which is a string. So here I've decided to name it Arena, which is where the battle occurs. So in this game, there's only just one scene. And we just, at the end of the fight, we just go back to the same scene and it restarts the game, basically. And the second param is basically the function that contains the logic that is going to run for that scene. So here it's where you're going to call a function that does all the drawing, everything, setting things up, etc. So here I'm just going to pass an arrow function, which is going to call our scene function. So above, I'm going to create a function, call it arena, and here I'm going to pass the k option, the context, and then here I'm just going to call the arena, and then I can just not worry about this anymore and write all my logic for my scene here. Ideally, when you would have more than one scenes, you would create a scene folder and have in multiple files, or each file a specific function that you export, and then just create a scene here and then call it, so that it is more organized than writing the scene code in the same file as the main.ts. But for this project, because of its small nature, I think it's best to just go with simple like that. It's easy to change, so it's not a big worry. Now you might see our first TypeScript error, or it's not an error, but yeah, it is an error basically. It tells you that k is declared, but its value is never read, so that's just one thing. But the other one is k is implicitly has the any type. So TypeScript, as its name suggests, works with types, and basically you have to specify your types, so basically declare your types, so that your code can run without errors, basically. Well, actually, in most cases, actually TypeScript oftentimes will never prevent you from running valid JavaScript code, even though it will complain. And the reason it complains, this is why it's beneficial. It's beneficial because for multiple reasons. Here, for example, k, what is that? I don't know. If someone unfamiliar with the code looks at this, they have no idea what it is. They have to do some digging. However, if I specify the type, I say, hey, k is to specify the type of a variable, of a param or a variable or whatever. You type the name of the variable and then the colon and then the type itself. And here the type is Kaboom.js. Now, where does this come from? Well, Kaboom offers you the ability to have types. It offers types for its well, in TypeScript you can create your own types, but Kaboom itself provides types as well. So it's thought in a way that works with TypeScript. So it supports TypeScript basically, to put it simply. So here I'm going to import from Kaboom the type Kaboom CTX CTX from Kaboom. The Kaboom context is imported. So Kaboom context is a type that is provided by Kaboom. If you click on go to definition, you can have the Kaboom.d.ts is where all Kaboom related types are defined. So I'm not going to go over all of this, but this is how you get to know which type is what. And in the documentation in Kaboom.js, you have the typings as well in the documentation, so you know what is what. All right, so now we have our arena. I think let's maybe draw something. You know what? Let's first run our code. So here we still have a squiggly line, but this is not an error, a TypeScript error. This is just a linter error that tells you, hey, this is not used. So you need to use it. Basically, it helps you avoid situation where you declare variables that you don't use, and then you pollute your code that way. Now to run our project, you need to type in npm run dev. And then later at the end of the project, if I don't forget, I'll show you how to get the output that you're going to use to upload your game to, for example, itch.io, Newgrounds, GitHub pages, etc. So here, run npm run dev into the terminal, and you'll have an address that appears here. If you click on that, I think I clicked, I need to open my tab. You'll have a tab that has your project. Now here is the previous project, the original code base I made for this project here for reference, but here you can see you have a checkerboard. If you have this board appearing, that means that your canvas has been initialized properly, and that means you can continue. Otherwise, if this doesn't work, then look at the console, try to look if there's any error message, any clues. If after a good debugging session you cannot arrive at anything, feel free to ask a question in the comments. Let's import our background sprites, so the trees, etc. that you saw in the original project. Here at the top, so usually, depending on how big the project becomes, usually you would want to have maybe an asset loader function that you call here instead of writing the logic for importing your assets here. But because of the smaller nature of this TypeScript project, I thought that it would not be much of an issue to just do it here. Here I've copy pasted to call of the load sprite function. I'm going to go over everything so that you don't copy without understanding what I'm doing here. I thought I wouldn't just type it out. It's going to take a lot of time for not a lot of benefit. So here, what happens? Where I used I used the Kaboom context and call the load sprite function. This is a function provided by Kaboom. It allows you to import an asset to be used in your game. It takes two params. The first one is the name of the sprite that you want to use and call that sprite by in your code. And the second one is the path towards that sprite. And here, the path is ./assets. So here, the way Vite does it is that whatever is in the public folder, you don't have to type in public. You don't have to write the actual correct path. You can just write a relative path because it will simply swap for you and make it as if your assets were already at the root level or in the source folder. So you don't have to worry about doing // public. So that would be the correct path from where we start. So here in our file here, we need to go 2 levels. So we need to go out of the source folder and out of, basically to go out of the source folder, you need to do ... And then once you're outside of the source folder, you enter the public folder by using /public. But this can be confusing, so you don't have to do that. You just need to do .assets, and even I think you don't even have to do dot, but keep it for now because once we're going to export the project, there's going to be an error that we can fix by just adding a dot in the path. Ideally, you would have your Vite config, but I don't want to overburden you with a lot of stuff like that, configuration stuff. So just do a /, which basically means the relative path assets /background layer the underscore layer underscore one.png. Same logic applied here. So now let's draw those sprites in our arena code. In our arena code, we're going to use K again, but call the add function. So the add function is basically how you draw stuff on the screen in Kaboom. So instead of having a on update loop, on draw loop that you hook into and then call your functions, Kaboom.js, usually most of the time you don't need to hook into an update loop or draw loop. You can just call the add function to draw stuff. But it does occur that sometimes you need to hook into the update loop, and that's why there is the on update function. But for now, the simplest way to get something on the screen in Kaboom is to use the add function. which will take an array of components. So Kaboom.js works with what is called components. Components are, the way I would explain it is that they're like functionality that you add to your game object. Game objects are what is the result of the add function, which is basically the entity, the game object that you create on the screen on your canvas. So just to illustrate, here you can see in the example, you have a bunch of components that are stacked, that are put in the same array. For example, the sprite components the sprite component allows you to draw a sprite. The positional component allows you to position your game object, the resulting game object. The area component allows you to have a hitbox drawn automatically around the shape of your sprite, your game object. The body components allows you to basically make your game object susceptible to collisions, etc. The health component is also a component that allows you to manage health. So there's a lot of high-level features in Kaboom.js that makes it why it's so easy and fast to make games in. It's faster than some game engines even. So that's why this advantage of higher level stuff with lower level I think is a great, like a sweet spot. So that's why I really like this library a lot. And you can also, for example, pass in tags to refer your game objects by. You can even pass here an object within to keep properties, so you don't have to use object-oriented classes mostly. So those are all things you can make use of. But now, just for our purposes, just to start simple, I just need to use this sprite component. And then the sprite component, you pass in the name of the sprite. Here, the name we're going to use is really, yeah, it's just background layer 1. So I'm just going to copy that, paste it here. And then we also need another component. That the other actually more than another component. We need actually three other components. First, the second one, sorry, is the positional component. We want to put the position of the canvas to be at 0, 0 in our canvas. So that's the top left corner of our canvas. We also want to use the scale component. So the scale component will allow you to zoom forward by 4, but by the number you pass in the params, your image. Here I want to zoom it 4 times so that it's going to take our whole screen. Otherwise, it's going to be too small. And the way it scales is if you're dealing with pixel art, it will scale it like without losing quality or becoming blurry, because it uses I think the nearest neighbor algorithm that allows you to preserve pixel art at various sizes. And then finally, the last one that is going to come in handy later on, so for now it might not make much sense, is to use the fixed component. So what does the fixed component allow you to do is that it basically allows you to have this game object not susceptible to camera movements. So regardless of how the camera moves, this game object will always be at the position 0, 0 from the viewport, from the camera's perspective. So it never actually, we can never leave it, basically. The camera can never arrive at the point where we can no longer see the background layer here. So now let's look at the result. If I refresh, wait a minute, doesn't work. That's strange. Okay, that's normal, sorry. I forgot one very important part is after defining your scene in the main.ts file, you always need to specify which is the first scene you want to go to. And you do that by using the go function. So the go function in Kaboom.js is used both as a way to specify the first scene of the game, but also as a way to change between scenes. So if you want to go from one scene to another, you just call the go function in the place where you want to, in your logic, if you want to move on to another scene and pass in the name. So now if I look back at the output, you can see that we have the first layer of the background. Now let's add the second one. So to do the second one, same logic. I'm going to copy it, paste it. The only thing that changes is 2 instead of 1. All right. So as you can see, the background is nice. It looks nice, superimposed on the previous layer, and it gives a lot of depth to the arena for now. All right. Now that this is done, we're going to, I think it's going to be a good time to work on the map. So tiled, basically. The way we're going to proceed is I'm going to open tiled. So you, at this moment, you should go and install tiled if you haven't. The link to do so will be in the description. Once you have the project set up, you need to do a couple of things. The first one, once you have tiled set up, you need to do a couple of things. So I myself will keep this as a reference so I can know what I'm doing, but you will probably have this closed off, and it will give, you'll have also the UI. If you have a bigger screen, it's going to be very small. So what I recommend doing is you go to your, I think in edit, you go to preferences, sorry. And then here in the, I think it's in here, the theme, you check this checkbox, I guess, and then increase the font size so that it can become visible for you. Like, otherwise, if you're using a 4K monitor, for example, as I'm using, it's going to be very small, to the point that you can basically not read anything at all. So that's why you should do that. All right. Now, once this is done, basically, you can go to the file, create a new map. Once you create the new map, basically here the width 30 by 30 is okay. It doesn't matter that much. As for the tile size though, we need 16 by 16. And then have this set to orthogonal, have this set to CSV, have this set to write down. If you don't have this, it's going to mess up the logic I'm going to write later on. So click OK. And then here you have basically a square that is going to be your whole map. Now, to have our tile set from which to draw on, you need to click on New Tile Set. And then here you have to click on the Browse button to select the source. All right, I have selected my source. So basically you need to point it toward your assets. So here on my computer, it's within the fighter.ts folder, public Oakwoods tileset.png. You're going to find, if you haven't yet, well, you should have by now, this in your project folder. And so that's how you will find it. And then you can click OK. And make sure this tile width and tile height is also 16 by 16 pixels, and no margins and no spacings. So 0, 0 for both of these. Click OK. And then here to zoom, you can click on Control and then use the mouse wheel to basically zoom. And then you can click on the mouse wheel itself while moving. So hold the mouse wheel, basically, pressing the mouse wheel, so you can just easily navigate around instead of using the scroll bars. All right, so we're ready to start drawing our map. Now I'm going to look at my previous map and see 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, let's start drawing from the 16th tile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That was a mistake. All right. Now I placed the first tile. It's not actually the correct one. It's the one near it. So here I'm going to replace. To replace a tile, you just click here. Now you might have noticed that it created a layer in the right side of your screen. So this is how layers are created. You can click on this button to create a new layer, but here we're going to keep it. So I'm going to just rename it to something more readable, I guess, or that makes more semantic sense. I'm going to call it ground. I think this is how I called it initially. All right. And now I think you can select multiple tiles like that. And then you can just draw it around. Now, yep, so let's draw this like that. Now let's save our file for now, and then we'll draw the rest that we need later on. So I'm going to hit Control Save and make sure to save it not as a TMX, but as a arena.json file. You just rename it in your browser viewers, your file explorer, sorry. All right, I have saved mine, called it arena.json. If I go back to the code editor, you can see that I've placed it inside of the maps folder and it looks like this. So using those keys, we're going to be able to draw the map. Now let's focus on just drawing the whole map. And then once the map is drawn, we're going to write the logic within the arena function in main.ts to display it. So here I want to have the same structure. So I'm just going to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24. All right. Whoops. I'm just going to unselect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I think that's good. All right. Save by hitting Control S. And I just want to make sure I haven't I have counted this correctly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right. Now, I think we need to have those tiles as well. So the rocky tiles can be found here. I think those are the one I used. I don't remember quite which one. So I'm just going to go back here to my original. I'm going to, where do I select? Oops, I don't think I can do that. It doesn't matter. Actually, it doesn't matter that much. Just count. I'm just going to count 1, 2, 3, 4, 5, 6. So 6. 1, 2, 3, 4, 5, 6. So I took this as the first one. 7, 8. And then save. Now it's the same thing again. So 6, 7, 8, 9, 10, 11, 12, 13. So 6, 7, 8, 9, 12. Wait a minute. So 6, 7, 8, 9, 10, 11, 12, then 13. Does it look good? Or it looks weird? It looks fine. Maybe... yeah, it's a bit hard to see if there's any difference. All right, and then 14, 15, 16, 17, 18. Okay, all right. So 14, 15, 16, 17, 18. So here are those two. And let's save. Now we're going to create another layer. As you can see, there are multiple layers. There is the boundaries layers, which is basically the hitboxes. Yeah, one thing I realized is that before that, we need to actually have the ground here as well. And those are 2 layers wide. So I'm just going to pick this one and then draw it here. Oops. All right, this should be okay. I save again using Control S. Now I'm going to create another layer, but this time around choose object layer. So basically, tiled offers you many types of layers. You can have the tile layer, which are basically tiles, only tiles, so that you select from here. You can have object layers, which can be like squares, hitboxes, spawn points, pins, basically. And this is what we're going to use for the hitboxes, just to delimit the shape of the hitbox, so the boundaries of our world. So that's why I called it boundaries of the arena, not world, but it's just an arena. So here, the way you draw this is you select the square tool here at the top, after of course having created the object layer and having selected it. And then here you drag, and then you drag all the way, and then you hold off, and that's basically it. Now be careful not to create another one by accident, so I did Control Z. I'm going to save what I have now, and we need two here that will be the boundary so that our fighters cannot fall off the arena. So here it was 1 2 3 4 5 6 7 squares. So I'm going to start. Whoops, no, that's not what I want. Control Z. Okay, 1 2 3 4 5 6 7. Save. And then the last one is 1 2 3 4 5 6 7 as well. So same thing. 1 2 3 4 5 6 and then 7 as well. Save all of it. And then the other layers we need after that is the decoration spawn points, basically for the fences, the shop. We're going to use those spawn points, those pins, just to know where to place them. So that's how we're going to go about it. Here, I'm going to create another layer. I'm going to call it, it's another object layer, and I'm going to call it decoration spawn points. I need to make sure that, first of all, you can drag and drop it below the ground, so that the whatever is drawn is going to be below this. So the shop, the way we're going to place it, we don't want the shop to be on top of those tiles. And just to make sure it's decoration spawn points, I have the name right, decoration spawn points. Yep. And then I'm just going to save. And then here we're going to use the pin tool here to decide where to put each of those. So here, let me just see. So for the shop is 3 on top of this one. So 1, 2, and 3. And then once you click here, you can go to the left tab and give it a name. And this is important because this is how we're going to know what to draw. So I need to give them a descriptive name that we're going to use in our logic, in our code, to know, hey, this is the shop. This is a spawn point for the shop. So let's draw it here. So I'm going to hit enter, and you should have a shop indication appearing here, message. So we have it here as well. So let's save. Now for the fences, where did I place those? Here, 3 after. All right. So 1, 2, and 3. Here we go. The name for this is going to be fence-1, which is the actual name of the sprite itself for the fence. So that's why it's fence-1, and we're going to put 2 of those. So 1 here as well. So let's put it as well here. And I'm going to call it, again, you need to call it fence-1. And I think we have everything we need for our decorations. Now the only 2 things left is for the spawn points itself, the spawn points layer. This is for the player 1 and player 2. Another object layer we're going to need to create. I'm going to call it spawn points. And I'm going to put it on top of them all. And where we're going to place those is here, 2 after the fence. So I'm going to do here, 2 here, so here. And this is going to be player 1, player -1. And player 2 is going to be 2 here, 2 here. So to here to here. It's here. All right. And then this is going to be called player 2. Let me see if I have the name right. Yep. Yep. All right. So we have everything we need and we're ready to exit tiles. We will not need to come back here ever again for this project. Make sure that you have the JSON file saved and that, yeah, you can close. So now here we're gonna, in the arena code, we're gonna write our logic to draw the map. So here we're going to need to create a utility that is going to allow us to load the JSON itself. So it's a utility function we're going to use just to keep things organized. So the way I would go about it is to just create a utils.ts file. And as you might have noticed so far, TypeScript isn't that different from JavaScript. We just had so far to specify a type here, but as we are going to progress in the tutorial, we'll have to create our custom types, and this is where I'm going to take some time to explain certain nuances about TypeScript. Alright, like I mentioned earlier on, what I'm going to do now is to write a function that is going to be used to load our map.json. So the way it works is basically the same as making a fetch call to an API, a REST API, for example. So here in the utils.ts file, I'm going to create a function that we're going to export. So we're going to first start with the export keyword, and then it's going to be an asynchronous function because we're going to use a lot of async await here. And after having done that, we're going to call it, I think a better name for that would be fetch map data. So yeah, fetch map data, and here we're gonna fill the rest that comes here in an instant. I'm just gonna close this to have more space, and then yeah, I think we're ready. And inside of that, we're gonna make a fetch call. That's why we need to use await. So the param we're gonna pass here is basically the map file path. So this is a name that I've decided for this argument. And of course, we are in TypeScript. That means you have to specify the type for this. So what would be the type for that? Well, to put it simply, map file path is just a path that we want to pass into this function. And it's going to be as a string. So we want to, like, if you think how you make usually a fetch call, if you're using an API, you're using the fetch function that comes from JavaScript and then pass in as a string the URL of the API you want to call. Well, here it's the same thing. The map file path is going to be the URL on your server, your local server, of where to find the .json file, the maps.json file. So here I'm just going to type it. Here we go. And then inside is where things are going to get interesting. We're simply going to make a normal API call. So let's first create a constant called response. And then here we're going to use the await keyword and call the fetch function. So I'm going to explain the await, async await, if you're not familiar with. Now, because I assume that a wide variety of experience, of people with different level of experience are watching this, I'm going to take some time to explain this. If you feel like you know everything regarding this, feel free to skip ahead. So basically, just to put it simply, we use the await keyword because this is an asynchronous call. That means that if you don't use the await keyword here, so as soon as you call this, your code will continue to execute what comes after. And yeah, that will be the simplest way to put it in our current case here. We don't want that because we want to only when the response is received from the fetch call, we want to execute the code that comes after it. If you wanted to, for example, make a fetch call and don't care what comes after it, because maybe it's the only line in the file, or you make multiple calls, or you use the fetch that you use a then callback here, then you would not need to use await. So here, in this fetch function, I just want to remind you that the fetch function comes from JavaScript, vanilla JavaScript, and we pass in the URL of the map.json, and here it's going to be the file path. So because this is hosted in our public folder, and it's hosted on basically the same server that we have where the game is going to be, then file paths becomes basically URLs. Now, once this is done, we have received a response. So basically, this line tells you to await that fetch finishes before proceeding on. So that's why the await keyword here. Now, what comes after is that as soon as we receive a response, what I'm going to do some error handling. I think it's going to be worthwhile to do. I haven't done this in previous tutorial because I thought it wasn't really necessary for the case, but just to instill good practice, good coding practice, because we need to, like, if you write code professionally, you have to make sure that that you do some proper error handling. Now, it's not a big deal for a game, but just talking from experience, like working as a software engineer, you need to do your error handling properly. So here, what we want is basically check if the response if there was an error. So initially I wrote in my original code base that you would do response.status. So by default, the fetch API returns back a response object. This response object has a bunch of properties, one of them being the status, and then you can check if the status is 404, and 404 means there is an error, and then throw an error within. Now, this is something that there's a better way actually. Instead of having to, specify a specific code, you can just use the OK property. And basically, by adding the bang sign at the front, you're basically telling that if the response is not OK, so that means the response status is not 200, this is a very short way of doing it, then throw an error. So we want to throw a new error. And here I'm not going to catch any errors because I actually want to throw here. And it actually helped me while I was developing the project, where I put the wrong file path and I did not realize it because I think either I put map without an S here. So that's why it's useful. So the error appeared on the console. So here what we're going to throw within this error, so this is the error object offered by JavaScript. You can instantiate a new error by just calling the new keyword and then the error constructor and throwing it. And then here, we're just going to take the response object and put the status text that comes with it. And usually the status text is the reason why this is not okay, basically. And for example, we're going to try it out. Hopefully I won't forget. If you try to call this with a wrong file path that does not exist, it's going to basically give you an error, and you're going to see what the error looks like. And then finally, we want to return the response.json if everything is fine. And one thing, I think you don't need to return early. Once you throw an error, it just will stop the execution of what comes after. So usually if you want to have an if statement that does something only in a specific case, you would write your logic here and then at the end have a return statement so that you don't go afterwards. That's a way how you avoid writing else if. So using only if statements, you don't need to use the else or the else if statement most of the time if you use this approach of having a condition that allows you to return early. And it makes your code usually more clear as well. So here, assuming everything is correct, because if there are errors weren't thrown, that means we wouldn't arrive. If an error was thrown, we wouldn't arrive here. So here we're gonna call the .json function, and the .json function, what it does is it gives us the JSON response. And if you remember, arena.json is basically a JSON file, and we are interested in this data. We want to receive this data. So here response.json, and we have to await it because it's asynchronous as well. That means that if you return without the await keyword, then the response.json will return you a promise, I think. Is there any information? Yeah, it returns a promise. And because of that, the promise is either pending or fulfilled. So it won't actually give you what you want. We want actually the fulfilled promise. So that means the actual result of the response.json, and not an object that tells us that the promise is pending or something like that. That's why you need to use the await keyword. You're basically waiting that the response is fully converted to JSON before returning what you have. All right, I think that's basically it. And we might as well write another function, the function to draw specific tiles. But I think we might hold off on that. I'm trying to think, is it going to be more clear if I do it now? It would be more convenient for me to do it now, so I can just exit this file. But at the same time, yeah, I think it's best that we wait. So let's go back to main.ts, and then within the arena function, which is basically our scene code, we're going to start writing the logic to basically get our map, and then from then on, once we get our map, we're going to draw it. So here, what we're going to do is we're going to get our map. And the way we were going to do that is, of course, by calling the function I just wrote in utils.ts. But the way I'm going to do it, instead of holding the whole response, I'm going to use this JavaScript syntax to just pick only the properties I want. I think this is called destructuring, if you're not familiar with it. And it allows you to basically select the specific properties from an object instead of storing the whole object. So here, the properties we are interested in are the layers, the tile width, and the tile height. And I'm going to explain where those come from. And yep, so let me just write this out, and then I'll do the explaining. So here, basically, we call the await fetch map data. And here I'm just gonna pass a random string just to show you how the error handling is actually working. Now, because we're using the await keyword, I think we might not need the await keyword here. Anyway, I'm gonna check this out if we need it or not here. I think we don't, but I'm not sure. Okay, so let me first import this fetch map data. So if you right click with VS Code, not right click, hover, quick fix, add import from utils. In case you're using a different editor, here's the import statement. Now, once you have that, I'm gonna save, hit save. Did I hit save everywhere? All right, now let's look at the output. So here nothing seems to be wrong. And we have a syntax error, JSON parse, unexpected error, uncaught error syntax. Okay. Maybe the error handling did not work properly. Okay, that's strange. So what's the response? So let's look at it. I'm going to go to utils. Here, I'm just gonna console.log the response just to see what is happening. Oops, response, not response. All right, so here, okay, you have something. Oh, status text is still okay, even in that case. Oh, that's strange. So even if you put a random URL, fetch considers it to be okay, and the status is 200. Well, in that case, that means the error handling is not working properly. And in that case, we're going to have to be careful here. Are you sure? I just wrote random stuff. What if I write a... It shouldn't work, but just want to see if there's any... Okay, now you have a not found. An error not found, and then it's a 400, which is strange, really. So if you put a random URL with no file extension, it will tell you that it's 200 and everything is okay. But if you pass in like a random file name that does not exist, but you add the .json extension, then it actually does the error handling properly. So that's something I just realized right now. So let's try to find a way to fix this. So the way I'm going to fix it is, I think we need to look back at the previous, when you put random, just a random route without an extension. Then you would get still status text, okay, and okay. Well, in that case, we can just go to the utils. We can simply do error handling before. Oops. I'm just gonna look again at the file, the response. Is there a way to know maybe the file type, headers, any information that could help me? Okay, redirect status, okay, no. Okay, I don't think there's anything that allows me to detect this error from the get-go, so we'll have to just catch it before it goes, before we make the fetch call. So here we need to check if the map file path includes, what does it include? If it includes a .json, then we want the reverse of that. So if the map file path does not include a .json, I think it includes or includes. Wait, yeah, it includes. If it does not include the .json extension, then we will just throw an error before we even get to before we even get to the fetching anything. So here I'm just gonna write a message. I'm gonna call it a file path or map file map file path is invalid or does not exist or is invalid. Is invalid is okay. All right. Now let's look at the result for that. I'm gonna just, oops, I'm just gonna save, and then let's look at what happens here. So okay, let's first look. Map file path is invalid, and then if I just put a random .json at the end, what it's going to be, not found. All right. Okay. Well, it works in terms of error handling, and I've realized also that you don't need to use the await keyword here because the awaiting is already done here. So for the receiving and the function that uses it, it looks like it's simply a synchronous function. So the code will not execute. Let me check that. So if I do console.log here, I printed out after fetch call. Now let's look at before. So we don't want that actually. So we actually need the await. Let me just put a valid path name now. Now if I just put arena.json, will this work? Okay, we need to actually like do .assets / maps. I think that should work. Not found. What's the what's the file, the path? So assets maps. Wait, yeah. Oh, it's not within the assets folder. So this should work now. All right. It printed out before the fetch call. So that means we actually need it. So I'm going to use await because I actually want to get this data before I move on. So let's put an async here. And now let's look at the difference. You see, we first make the fetch call, we get the data, and then we print out what comes next. So that's why it's important to keep it. All right, we have this. And now what we need to do is, I think, let's create our map object, and then we'll write the logic to draw the map. So now that we have the layers, the tile width, the tile height, oh, I forgot. We need to explain what this is. Okay, so if you look at your arena.json that you've exported from tiled, you can see that there are a bunch of properties. It's a basic JSON file, and those properties that interest us are the layers property, the tile height property, and the tile width property. Tile height and tile height and tile width are important because it's going to tell us how to draw, like what is the size of each tile and how to like compute where rows finish, etc. You're gonna see it later on. The layers property is the most important one. It provides an array of layers objects. So those are the object. For each layer, there is an object. So if you remember in tiled, we have 1, 2, 3, 4 layers. So we should have 4 elements, 4 objects, 1, 2, 3, and 4. And in each of that, you have the name of the layer, and whenever or not it is what's the type of that layer. If it's an object group, you'll have a objects array with each object describing each object, so the position, etc. This is going to be useful for us so that we're going to be able to place the objects where we want them on the map. However, for the tile layer, I think it's this one, it gives you a data prop with an array like this that basically tells you what number the tile is, and this is what we're going to use to actually draw the various tiles. So I hope this explanation was clear, and it will hopefully get clearer even when we start working on the layers, etc. All right, so let's jump right into it. And I think, yeah, let's create a map object, game object. So in Kaboom.js, your game object that you create, like the two we've created here, can be assigned to a variable or constant. And then once you do that, you can actually use that game object and give it child game objects. And the way you give child game objects is by taking the name of the constant or the variable where you have stored your game object and using the .add method on that object, which will allow you to add another game object and create it the same way that we've created this game object by using an add function, and inside of it used an array of components. Now for this map, the idea behind it is that we put all the elements, not all, but most of them, under a child of the map. And that way, when we want to move our map somewhere else or on the canvas or position it in a certain way, it's going to move all the children with it. So it's going to make everything easier to organize. All right, so the only component here we need is basically the position. We're going to put it at 0, 0 and not touch it that much afterwards. What is useful, again, of having all the children appended, all the tiles and even game objects like the players, etc., as childs of the map game object, is that if we want to scale our game, so zoom in, for example, when you're dealing with pixel art, you can decide to just scale the camera or scale all the game objects. There are two choices basically. Either you scale the camera, that means you don't resize the game objects or the sprites at all. You just zoom the camera, which will give you essentially the same result. It will just look bigger. Or you do the reverse, and the reverse is basically you scale all the game objects to fit with your viewport so that every sprite can be looked at clearly. Now, there are various advantages and disadvantages to those approach. Mainly in Kaboom.js, the disadvantage of scaling basically the map itself, all the objects, instead of zooming the camera, is that for physics, if you use physics, you have weird behaviors. And I'm hoping to maybe show it to you. That's why if you're dealing with pixel art, and you need to use physics or you're making a platformer, it's better to just zoom the camera instead of scaling all your game objects. Otherwise, you'll have this issue where everything trembles, like a weird glitch like that. Okay, so now we have this map object, and I think before we... Okay, let's try by drawing a single object group. So the spawn points, let's try spawning in some squares. And then once we do that, I'm going to stop, go back to the utils.ts, hopefully, and write the logic for drawing every single tile. And then we can move on. All right. Maybe not rectangles. Let's actually draw maybe the decorations layer. That way we get something done for real instead of having some mock-up data. So what we're going to need here is we're going to have to create a types.ts file where we're going to store some custom type definitions. So in TypeScript, you can define your own types as well. So the simple types like string, number, array of string, array of whatever, Boolean, etc., are primitive types that are already readily accessible, and I've used them here where I type this as a string. Now, if you want to create more complex type, you need to use a type definition for it. And Kaboom.js provided their own types, but it's not enough for it. We want to create our own types, and you're going to see why in a moment. So what I would do here is to draw something from the map. I'm going to write a for loop. So first of all, I'm going to declare a variable called layer. And then I'm going to create a for loop and use layer of layers. This is equivalent to the for loop that is in Python, where it's layer in layers, if you're familiar. So it allows you to, it's a very simple way of writing a for loop compared to the traditional for loop where you first declare a variable inside of the for loop and then you check if that variable is inferior to some value. And the third statement inside the for loop, in the for loop declaration is I++ or something like that to increment it once the body of the for loop is executed. Now that's a way to do it simply. Now you might find something strange. Why did I declare a variable outside of it? And this is because we're going to need to do that because of TypeScript. We're going to need to type this in order to benefit from type safety from the... It's hard to explain now because in tiled, as you have seen in the arena.json, there are different type of tiles. There are the object group tiles and the tiles layers. Sorry, you have the object group layers and you have the tile layers, and those two layers have different properties. One that varies, the most notable one, is for tile layers, the data property is there, and the objects property is not, and for the object group layer, it's the reverse, and we have to deal with them differently. That's why by having the typing done, we can make sure that we only try to access certain properties when we're sure that the type of this layer is a tile layer or is an object group layer. So I hope that was clear. So here what I'm going to do is inside of this, I'm going to write another if statement. And this if statement is simply going to be a, what is it going to be? Yeah, okay. So in this if statement, we need to check two things. We need to check if the layer dot name is equal to a decoration spawn points. Where I'm taking this name from? Well, simply from the tile. I've named it this way, so it's using that name in the JSON. So that's why we have access to that as the name. And for the layers comes from here, if you remember. That's why we're able to do the for loop. Just wanted to clarify that. As for the other condition we need for that if statement, we need that to check the layer type for it to be an object group. We'll write the logic for this later on. So I'm just going to write to do. And now, for now, what I'm going to do is actually thinking about it, it might not be necessary to. Actually, we can continue, but we'll have to first import the assets we need for the house, the shop in the game. If you remember, there was a shop in the background, so I'm just gonna take I'm gonna copy and paste the import declaration for that using the load sprite function. Let me just find it real quick. Where is it? Where is it? All right, it's here. I'm gonna explain it, of course, just to be faster. Okay, so what does this do? So I just pasted this right below this. It will import a sprite, load a sprite. The correct terminology is load, not import. That I decided the name would be shop in my code. I've passed the file path, and a third optional param when you're using the load sprite function is this one, where you can pass in an object that will specify how you want to slice your image into pieces and how you want to configure your animations using those pieces. So if I'm going to here, I'm telling Kaboom by using the slice x property that I want to make that I have 6 squares. Let me just put I have 6 frames in my image on the horizontal axis. On the x-axis, I have 6. So that's 6 objects and one row. So yeah, this might look strange. Why is it slice x where there is like a single row and 6 columns? Slice x is I'm making 6 slices on the x-axis. So I'm cutting like that 6 times. And slice y is 1 because there's just only one image. So I'm making basically a single slice on the x. Wait a minute. So to put it, let me just, maybe a drawing would be best. So I'm just going to copy the image. I'm going to open Excalidraw. Let's paste it. So here we have the image in Excalidraw. So because I'm using Excalidraw, there's no transparency here, but your image should be transparent. So the slices we're making, if I just put a here, we have one slice here. I'm going to copy and paste this, a second slice here, a third slice here, a fourth slice here, a fifth slice here. Actually, it's 4 slice. It's 4 slice that gives you 1, 2, 3, 4, 5, 6 frames on the y-axis. Well, it's very strange, in fact. But if I go back, because we're going to deal with this a lot later on, and I think the name slice x and slice y are just bad names. But basically, you're just specifying how many frames there are in the horizontal axis, how many frames in a row for slice x, and how many rows, how many frames in a column. So there's 1 frame per column, but 6 per row. So just to repeat, slice x is the number of frames in a row. There is 1, 2, 3, 4, 5, and then 6. And slice y is the number of frame in a column, and there's 1 frame per column, as you can see. 1 frame per column. All right, hope that was clear. And then once you have done your slicing, you can specify the animations. And the animations is specified by using the anims property and passing in here an object where you define your name. So here I decided to name my animation default. It's an arbitrary name. You could have selected anything else, and it can be a string and not just a name like that. So if you want to, for example, have your animation called hello world, you can. Hello 2, I guess, you can. Now I'm just going to revert back because I want to use the default. And then here inside this object, you need to specify what's the starting frame, and what's the end frame, and wherever or not, this is optional, if your animation is looping or not. There are other properties like the speed, but for this specific shop, we want an animation that just keeps on going forever in the background. The reason we want it to go forever, because there's a chimney and it's puffing out smoke, and we just want to like have this animated all along the fight in the game, basically. So from 0 to 5, what does that mean? If I look at the image, the way Kaboom.js numbers your image is by using 0 index numbering. So here, this is not called the first frame. It's called the 0th frame. 1st frame, 2nd frame, 3rd frame, 4th frame, 5th frame. That's why here, by telling Kaboom from 0, you're telling him start here, and to 5, you mean finish here. And then that's your whole animation. And then loop this animation when it's run. So, yep. This doesn't do anything yet. We have only loaded the sprite. We need to actually play the animation for it to loop forever. Until we stop it, of course. So here in the to-do that I wrote earlier on, we're just going to create that object. So here, I'm going to have a for loop. So here, this for loop is going to, again, iterate through a bunch of stuff. So here, we can just declare within object of. For this, please, I'm going to explain this, just not right now. I haven't forgotten. There is a nuance to explain here, and it's not going to be clear for now. Hopefully, I will not forget when I come back to this, though. Because sometimes I can't forget. If I forget, feel free to ask in the comments about it. So here, of layer dot objects. You see, here it's fine to do that. The objects property is only available for layers of the type object group. And the reason for that is simply because we want the, if you look at the arena.json, you can see that, let's say, I think it was this one. This is the decorations. You have this objects property. We have access to it. If I go back to main, for each object inside of that objects array that we have in this property, this array, so all of these, we're going to write a logic to draw that stuff. Now here, because we have given different names to each of those objects, if you remember, the decorations, we have 3 decorations: the shop, the fence 1-1, fence dash 1 again. So those are the 3 elements, and we need to differentiate between them, because we're going to run different code depending on which decoration it is. All right, so what comes next? I'm going to use a switch statement instead of having another if. I think it's going to make our code much cleaner. What I'm going to do is have this switch statement that is going to check for the name, because each object inside of this array has the name property. If you look at the arena.json, you can see this clearly. You have the name property defined as shop, name, fence, and fence here. All right, so in that case, we're going to, as I said, use a switch case statement. So if the case is shop, so that means the object name is shop, we're going to add to the map a child game object. This child game object is going to contain the following array elements, like array of components. So the first component we're going to use is, of course, the sprite component to define the sprite, and we're going to want to use the shop sprite that I've defined here. We also want to play the animation immediately, and the way you do that is that the sprite component takes a optional second param, which is an object that allows you to define many things. It can allow you to take a single frame from your sprite, or it can allow you to define what a default animation is going to be, an animation that is going to start playing as soon as the game object is created. And here, to do that, you specify the anim property and call the name of that animation you want to play. And here it's the default animation. All right, once you have done this, there's still a bunch of properties. We need to actually position our object, and that's why I'm going to use the positional component, the pos component, and pass in object.x and object.y, which are the coordinates given us by tiled to know where to place the object. Those are here for every single object here. For tiles, it's going to be much different. We don't get all this information. We simply get the number of the frame, and that's basically it. You have to, the rendering order. It's top to bottom, the top to left, and then they come back. So top down. I don't know how to explain the order, where you just draw each row starting from the top, from the left to the right, and then you go to the next row, etc. This is how we have set up tiled to draw maps, and it's the default way. If you remember in the options we've checked, you probably had, I probably told you to keep the top down or top right, I don't remember the name exactly, option. So here, this is how we get the positional, where to place this game object. We also need, well, actually we don't, we need the area component. The reason we need the hitbox. So the area component, I think I've explained this earlier, but I'm not sure, so I'm going to do it again. So the area component allows you to create a hitbox for your game object. By default, it will take roughly the space around your sprite, but you can specify specific shapes, and specific sizing and position, or where to put that hitbox. And we're going to see how to use area in those cases later on, when we're going to deal with the players. But for now, one of the advantage of the area component is that it's not an advantage, but the reason I'm using it here is because it's required if I want to draw my sprite from the center instead of from the top left corner. By default, in game development, you would probably, in other libraries and frameworks and even game engines, sprites are drawn from their top left corner. And you can change that, either draw it from the center, and we want to do that. And to do that in Kaboom, you have to create that area component, which is basically a hitbox. It doesn't take collisions by default. It's just, you can know when it overlaps with other objects, etc. But for the actual collisions to happen, where there's like physics, etc., you need to use the body component. But for this case, we don't need. What we need is to call the anchor component and specify that we want to draw it from the center. You have many options here. You have left, right, top left, etc. So by default, it's top left. So I would recommend looking at the Kaboom.js.com documentation. There's a bunch of information on how to use those stuff, each of those components. And you can even create your own your own components. I haven't had the need to do that for now, but yeah, just for your information if you're interested. And then after, of course, having this case, we can break. Now, we have a second case, which is the fence one. When we want to draw the fence, same logic. I'm just gonna maybe increase here, scroll down, sorry. I'm gonna use map.add k.sprite. Here again, fence. Oh, we haven't imported the fence. That's it. Yeah, we haven't imported the assets for this. I'm just gonna do it at the top here, right below where we imported the shop. So let me just do that quickly. So I don't have to write it manually. All right, here it is. It's a single line, not much trouble, just the name and the path. There's only one frame in that image anyway, so it doesn't matter that it doesn't require us to have a third param. So just to look at it, this is how the image looks like. Now here, now this should work, but now we need to also add all the objects, components. And here it's going to be different, because the way tiled works is that you can specify pins for where to place your object, and it's going to place it, but you don't have much granularity in terms of where to place it exactly. It seems to be snapping to a certain grid. So here what I'm going to do is I'm going to take the object X and object Y position, but for the fence to actually fit in, and you're going to see in a moment, for now let's not do it. let's look at the result, and then after I'm going to do it, I'm going to add an offset here so that it really corresponds and fits in nicely with the platform, the ground, basically. Because if you look at here, I've put it here, but it's going to be a bit below or above, and I cannot in this editor have like really granular precision. Maybe there is a setting I should deactivate here, but I'm not that familiar, so I don't know. If you know of any tool or any setting in Tiled to basically have pinpoint extreme precision where to place those pins and for the object layers, feel free to add a comment. It's going to be beneficial for both me and I think others as well. All right, so we have the sprite fence -1, the positional component here. Let's also add the area component, as I said, because I want to draw it from the center. Draw that sprite as well from the center. And then here, just to make sure. Of course, you need to break after each case in a switch case statement. So you've seen so far, it isn't that much different from using normal JavaScript. Where it's going to be different is really in the typings. So here. But for now, there's no issue because there's no need for now. But later on, when we're going to add the tile layer, it's going to cause some issues. That's why we're going to need to type to make things clear. All right, so here it is. And all right, so let's look at the result. Okay, failed to load image, assets, failed to load image, shop anim. Okay, I guess I messed up the imports. Assets, background entities. Oh. I made a mistake. I put it outside of the asset folder and in the public folder. Put all of those assets here. It does happen, sorry. All right, now it should work. If I look at the result, you can see that it's drawn. For now, you cannot see the issue with the fences. It's only when we're going to actually draw the ground that it's going to appear. And now you may have noticed that, hey, your sprites look small. What's up with that? Well, as I said, we're going to zoom in instead. So for the background, I've preferred to zoom in the background itself, but we could have proceeded without that. I think if we could have removed, let's say I remove the scaling here, and then just zoom the camera, I think this would be better. As I said, the reason that we're doing this instead of scaling up is because it could cause issues. Now, of course, because of that, it's not going to fit nicely. So yeah, I would rather just keep it that way, just so I don't have issues later down the line. The whole reason I try to instead zoom in the camera later on is because of the issues I had with physics. So I completely forgot that I scaled the background 4 times, but it will not matter in the end because it's fixed and yep, it won't matter. I think I hope I actually did what I said. I just zoomed in the camera. So let's do that. Let's zoom in the camera already so that we don't have issues later on. So where I'm going to do this, I'm going to collapse the for loop here, and right below it, I'm going to write this code. I'm going to call the cam scale function. This is a function from Kaboom that allows you to scale your camera. It can take either one value or it takes 2. In vanilla JavaScript, if you try to use 4, it would let you. But because we have TypeScript, now it's more strict. It wants a vector 2. So you want to, TypeScript wants you to define both the X and Y axis on like how much scale you want, even if they're the same. So a way to get around that, you use the vector 2 and you just pass in one param. The vector 2 function is from Kaboom that allows you to create vector 2s. As you can see, vector 2s are basically just object with X and Y properties. Basically, it's just an easier syntax to create them, a more convenient one. And then here by just passing 1, it's just going to create the same value. Just going to add the same value for both X and Y. Let's save. Let's look at the result. Now you have seen that, yeah, it looks, there's nothing here because by zooming, we have lost the shop and the props from the viewport. The way we're going to fix this is just to change the position of the camera itself. Now, we could have done this better, thinking about it. We could have, instead of moving the camera, just made sure to just set the map position to be the correct one. And I think it's going to work if you do that. But just, I know that sometimes I write some code and I don't document myself, and if this would be fine to do. And because it's a tutorial and I'm basically refollowing my steps and trying to explain everything I did along the way, if I mess up this, it's going to probably cause us issues later down the line. And I just don't want to make this tutorial take more time than it needs to, because I would like to respect your time as well. But that's the reality of like software development. You write your code, sometimes it works, but it's not optimal. Sometimes it works right now, but it doesn't because you didn't design it properly, etc. So that's why I actually like the fact that I can come back to older projects and make them in TypeScript, because I can make like much better decisions that I've made originally. So yeah. So I'm not comparing this code base with the previous one, like one-to-one, but I've took some time to just look at what I wrote and seen that I had some glaring bugs and issues. That for the tutorial it's fine for introducing someone to Kaboom, and it was my first long form JavaScript tutorial on my channel. So yeah, I've learned tons of stuff regarding Kaboom itself, which means that I would do many things differently today, and having the opportunity to do it in TypeScript right now allows me to do that without making the same content twice. Basically, it gives me a way to revisit old things while keeping things hopefully beneficial for you if you're stumbling on this video, if you watched the JavaScript one already. So that's why I thought I would make it and also dive into TypeScript. All right, so here is how you modify the camera position. I'm gonna go over this line. It might look complicated, but it's really not. Here we call the CamPause function. CamPause in Kaboom.js allows you to get the current position of the camera. So if you were to store this in a variable, if you were to put, for example, constant and call it current CamPause, it allows you to store the position. But it also allows you to set the camera position by passing in a vector2. So here it's a vector2, but I think, yep, if you hover over it, you'll have the typing position vector2. And now I think in vanilla.js Kaboom, you could do just that. Or I think you can do it as well. Yeah, we don't need the extra vector2 here. So either you pass in a vector2 that you create from the vector2 function, or here, here again, for camscale, I just realized that you could have just passed this way, 4, and it's actually shorter than having to do k.vector2, just so you don't have to write two values, two numbers instead. So it's, yeah, this is shorter end. So here, k.center.x minus 450. So by using the k.center Kaboom function, the center Kaboom function, allows you to get the position of the center of the canvas, regardless of the sizings, etc. So you can basically position your camera relative to the center. So here, by center gives you just to make things clear, center gives you a function. Center is a function. When you call it, it gives you the vector2 for the center of the canvas, and you can have therefore access to the .x, the x position, and the y position. And here what I'm doing is I'm accessing the x position and then subtracting a certain amount so that what I've drawn, the map, appears on the screen in a position I want it to, and minus 160 as well. So just if you're new to game development, the more you increase the y-axis, the more down you go. The more you decrease the y-axis, the more up you go on the canvas. This might not be something intuitive for some of you, so just wanted to mention it. So just to repeat, the more you go down in the canvas, the position, the Y position, the more you increase the value of Y, the more you will go down in the canvas, and the more you increase the value of Y, the more you go up, which is like counterintuitive. All right. Now we have this, and the values here are values that I've found that looked good, worked well, would put the objects where I wanted them to. Now here it looks weird for now. It looks weird that this is cut off, but it's going to look natural when we're going to have the ground here. And as I said, I need to have an offset here of 6, push this 6 on the y-axis so that it can like fit with the ground here. So let's do it actually, because you can already see that the fence here is not on the same level as the shop, and we want to fix that. So if we go here to the for loop where I've drawn the fence, add in 6 pixels, 6 to the position, the Y position. And as I said, the more you add on the Y axis, the more you go down. So if I go here, you see it looks relatively centered. Anyway, with the tiles we're going to draw, it's going to be looking fine. All right. Let's go back to our code now, and let's write the logic to draw the tiles. And the way we're going to do that is I'm going to go to the utils.ts file and create another function. Now this function is where the drawing logic for tiles is really going to be written in. And I've taken this from the previous project I made, which was a Zelda-like. It was a four-part series where I built a small Zelda-like game, and it was the first time I used tiled to draw maps. All right, so let's export the function we're going to write. I'm going to call it draw tile, and within it, we're going to write a bunch of logic, but we need a couple of arguments. We need, first of all, to pass the context. As I said, everything that we draw is through the K function, so the K context, the Kaboom context. Everything we draw, every Kaboom function, so I need it here, so I don't have to import from the, well, you could have use an import statement and just import the context on every file you need it, but I thought, you know what, it's best to just pass it as an argument. I think would result in cleaner code. All right, so now we need to type this as well. So as I've done it earlier on, I've used the typings provided by Kaboom, which is the Kaboom context. Here, quick fix, add the import. Now the second parameter we're going to need is the map that we've created. And this is of a type game object, or game obj, or something like that. And here we need to import it. Now, you might, if you're coming from a traditionally typed programming language, you might find this weird. If we, in main.ts, when we created our game object, the map game object, we didn't need to specify the typing of it. And that's something that TypeScript does for you. It's implicit typing. I think Kotlin, now typed programming, like main typed programming language like Java, don't require you to type this. Maybe Kotlin. I remember Kotlin did not require you to explicitly type this. You can do it if you want, but it's not necessary when you declare a variable most of the time, of course. It's only necessary when you want to pass as a param or stuff like that. This is where typing is going to be necessary, but by default here, you don't need to type declarations like that. Even here, here it's considered any, but it doesn't give you any errors. I think what happens if I try to type this? Can I type it here? Identifier expected, no. Yeah, so usually TypeScript, if there is an issue, will give you squiggly lines and tell you to type this. And for now, it hasn't. Here, the squiggly lines are for the fact that I'm not using them yet, but we're going to use it soon. All right, so here the draw tile function. We have the second argument specified, defined. Now the third argument is going to be the layer argument. And here the typing is not defined yet. I haven't done it yet, so let's create our first custom type. So I'm going to stop here. I'm going to go to the types.ts file I created. And here I'm going to put every type definition I use that I need, that are going to be needed in more places than just one. If I create a type that is really only needed for one file, I just will put the declaration in the same file just for convenience. Otherwise, I think it's best to just put them in like types.ts file that you can import them from. So this is where TypeScript really comes into play. And we're going to need to create a couple of types to really model the way the tiles work, the way layers work. So the way we are going to define layers. So here, I'm going to create a first type. This type is This type is going to be called the tiled base layer. So I'm going to create our first type, and this type is going to be called the tiled base layer. This is the name I've decided, and this is how you declare a type in TypeScript. You have the type keyword, the name of the type, equal, and then the brackets is going to contain all the fields for that type. So what does a tiled base layer will contain? Well, it's going to contain everything, every properties that is both available in layers that are of the tile type and layers that are from the object group type. So by default, like if you look at your arena.json, you will realize that for those layers, for example, here we have a object group layer, it has basically the same properties as the tile layer, but the only difference is really the objects here property is not there here, the data property is not here in the object group, and the type property is not available as well. So in order to keep things organized, we're just gonna have this base type from which all the common properties are kept. That way it's going to really make the declaration of our other specific types like the tile layer type and the object group tile much simpler to do, and we won't have to repeat ourselves. So here I'm going to create an ID. This is the first field. The way I know this is by looking at the area.json. So a tiled layer by default, not a tile layer, a tiled layer, so a layer coming from the tiled export arena.json, has an ID, which is of the type number, has a name, which is of the type string, has a height, which is of the type number, has the width, which is of the type number as well, has an x coordinate, which is of the type number, has a y coordinate, which is of the type number, a visible property, which is of the type boolean, and an opacity property, which is a type number. This is what tiled gives us. The tiled export gives us. Now we don't need to export that base type because we aren't going to use it alone, but we are going to use it here to create the specific types we need. So the type we're going to create now is something I call the tiled tile layer. So that's the type. The way we're going to do is we're going to use an intersection in TypeScript. I'm going to explain what it is, but first let me just write it out. So I have tile base layer. We take our type we've defined previously, and by using the and sign here, we can then define the rest. So here, so basically what this does is that we want the tiled layer type is a type that contains all the properties that are in the tiled base layers and the following properties. The type property, of the value layer, tile layer, and the data property of the type number. So here it's not a type, it's a specific string. Well, it's a way to type. So you can type strings by using the string keyword, but if you want something very like a specific string, I want this to be the type, you can just write it out. So the tile layer string. Now this is where I hope the explanation was clear. There are some nuances I'm gonna go over, but first let's create the other type, and then we're gonna have to do something to add an extra property here and an extra property here, and I'm gonna explain why. All right, so here number brackets is a way to define that the typing for data is an array of numbers of the number type. And here we're going to export another type, and I'm going to call it tiled object layer. And again, it's going to be tiled base layer, everything that is in the tiled base layer, plus the type property with the specific value object group. This is because of that. You have type tile layer, and you have type object group. And then here we're gonna need the objects property. And here the object properties is, what is it? Well, it contains arrays of tiled objects. So it contains an array of object, and we need to type this as well. So the way I'm going to do it right now is I'm going to maybe be above it, create, or below it, doesn't matter really. So I'm going to export another type, and I'm going to create that type called tiled object. And here it's going to contain everything, every property that is in a object that is within the tile. So here, just to illustrate, so things is very clear, in the object group layer, there is this objects property, and this object property, it's an array. Objects property, sorry, it's an array. This array contains objects that have the following properties, and we need to describe this, type this out. So the way we're going to type it, basically take the fields here and put the type. So here, for tiled object, this is a name I have arbitrarily chosen. The same thing as this and as this. So those are types I'm creating for myself. So here we have a height of the type number. We have an ID of the type number. We have a name of a type string. We have a point, a property of the type boolean. We have a rotation of the type number. We have a type of the type string, a type property that has a string as its type, a visible property as well as a boolean, a width as a type number, x position number, y position number. Oops, forgot this. All right, did I make a mistake? Yeah, I forgot to write. So now we can simply have an array of tiled objects. So the way you do this, you declare it this way. The same way as this, we use that typing and we use it here. Now I don't remember if I needed to export this and I'm using it. If I was using it elsewhere, I'm gonna keep it for now. And yep. Now there is a nuance. There's an issue, and you might have you might have not noticed it. So if I go to, let me just check. If I go back to the utils, I wanted the layer to be a tiled tile layer. And if I go to the type, we have a tiled tile layer, a tile base layer, and whatever this is. Now the issue is this. This is called an intersection. An intersection in TypeScript. And as I said, it takes everything here, and so this type is described by an object that will contain all these properties and those properties as well. But the issue is that you could have an object that would be typed as a tiled layer and would contain maybe it's I made a drawing for this, so I just want to make sure that I'm explaining things correctly. But I think it's a good time to just explain, you know, the difference between TypeScript unions and TypeScript intersections, so there aren't any issues with those typings if you were to use them as is. However, if you want to do a union, so you want to create a third type, this type is called tiled layer, and we want this type to capture both these and these. So we want a type that is going to a tiled layer. The type tiled layer will basically, it can be either a tiled tile layer or it can be a tiled object layer, but not both. However, in TypeScript, what the other tool we're going to use is the union. So to do something like that, we're just going to use the tiled tile layer, the bar like that, the pipe operator, I think it's called, and then tiled object layer as the second type. So if you were to just leave it at that, you would maybe think that, oh, okay, so it's a tiled layer. The type tile layer is either a tiled tile layer or a tiled object layer. But the way union works in TypeScript and union works in general is that this is not the case. This is not an exclusive or. That means that in a union, you can have an object typed as tiled layer be at the same time a tiled tile layer and a tiled object layer, both of them. So it's not this or that, it's this or that or both, the way it's understood. So it's not an exclusive or. So in computer science and math, when you're dealing with sets, you have this notion that the or it doesn't only mean one thing or the other. It means one thing or the other or both. To mean one thing or the other, like we use in English, etc., you need to use exclusive or. So exclusive or is the terminology that logicians, mathematicians, computer scientists use. To illustrate this and why this won't work, that's why we need to add another property. We need to add here that the object's property must be of the type never. And the data property needs to be of the type never as well in the object group. So let's put them in the same order. Yep. So here, let's put data here as never. And only by doing this that you'll get an actual exclusive or. So when you type tiled layer, it's either this or this. So if it's this, it will never have the object's property if it's a tiled layer. And if it's a tile object layer, it will never have the data property. And that's how you get an exclusive or. Now, to illustrate this further, here's a diagram. So in this diagram, we have it's a diagram I made explaining the difference between intersection and union. So here, let's say we have two sets. We have A and B. In A, we have the following, a type with the following properties: ID, name, height, width, X, Y, and visible and opacity. In the B, we have the tile layer, the data layer, the type property, the data property, and the objects property. So those are the members. If you think of it, each of those properties are the members of the set A, and each of those properties are the members of the set B. Now, the intersection is the middle part. It's basically the case where you have objects, you have type, let's say, that have both the members of A and the members of B. So you would have theoretically an object that would have both ID, name, height, width, x, y, visible, opacity, type data, and objects, both of them. The union, however, is different. It's what's in A, so you could have only what's in A, only what's in B, or both. So you could have a type, an object that only has the members of A, another object that only has the object of the members of B, and an object that only has both the members of A and B, and all of that would be defined under the same type. That's why I wrote the never property for both A and B. This is not explained here, but this is why I did it here, so that we can get an exclusive OR. It's either what's in A or what's in B, not in the middle. Hope that was clear. And yeah, so that's what was the definition, like the explanation. All right, we have defined a bunch of types, and by using the never trick here, we're able to force our union here to be exclusive, to only have either one or the other. So a tile layer can only have the property, the members of the tiled tile layer, or the members of the tiled object layer. And yep, so that's that. Okay, I think we're ready to jump back in our code. And so let's go back to utils. I really hope this was a clear explanation. I did my best with the drawing. If somehow it's not clear, feel free to ask in the questions or leave a comment. Or if you have found a better explanation, feel free also to chime in the comments. I would really appreciate it. All right, so here, the third param I wanted was basically pass the layer, but I want to make sure that we'll only draw the tile on a layer that is of the tiled tile layer. And otherwise, the logic inside of the draw tile function does not apply to an object layer. So by typing this, it's going to make clear to whoever reads the code in the future that they know, okay, this function, it takes in a tiled tile layer. So that means it deals with the tile layer and not the object group layers. So I hope this illustrates the utility of TypeScript and how it can even offer more safety, and more importantly in this specific case, how it can make your code more readable for other people, other software engineers that will work with you. All right, so the next arg is tile width. Nothing special here, it's a number. And finally, tile height, which is a number as well. Now if I go back here, we have everything defined. And now I can just write the logic inside of it. So the logic for it, let's jump right into it, and then we'll use that later on. We need to have a variable. I'm going to call it number of drawn tiles. Initially it's 0. We need to keep that track. We need to keep track of that. The reason for this is that the way we're going to draw our tiles is that for each tile, we're going to draw it by row. So we need to know when a row finishes. And by keeping keeping track of the number of tiles that are being drawn, we're going to know basically when to move on to the next row. So I hope that was clear. Here, I'm going to create a constant. I'm going to call it the tile position. And it's going to be a vector2. And it's going to keep track the position of the current tile we want to draw. So we're going to update this. And this might look weird because, const, usually it's supposed to be constant, not change. But in JavaScript, a constant that refers to an object, the properties of that object can change. And this is something that can trip you up. So be careful. This is not like from other programming languages that are more strict, I guess, where if you declare a constant, well, it's constant. You cannot change the properties, you cannot change anything. But in JavaScript, somehow it allows you, and that's JavaScript for you. All right, so maybe I should put a let here, but you know, if you're familiar with JavaScript, if you're like used to JavaScript, I think you would know this. So yeah, all right. So here we're gonna have a for loop. We're gonna iterate through the tile. So const tile of layer, and then here, this is where things are gonna get. Yeah, we're gonna need a condition. What we want here. This is actually the first case where I haven't found a way of eliminating an else statement. So I think it's pretty necessary here. Okay, so we have an if. We want to check if the number of drawn tiles modulo, the modulo operator, I'm going to explain it. It's basically the remainder of the division. We want to divide it. So what we want to do is divide the number of drawn tiles by the layer.width. And we want the remainder of that division to be 0. This, if it is 0, it will tell us that, hey, we need to change the row. We need to move on to the next row. And the way we're doing this is by using tile pos x. We simply set it to 0, because the way it works is that the top left corner of your canvas or your image is always 0.0, is the 0, 0. And as you move on the x-axis, it increases. So what we're doing here is we're getting back to the left side, and we're incrementing the y position by the tile width to move on to the next row. Tile height. That's why it's useful here. And then in the case where it isn't, well, actually, I think we can just, yeah, we need this else because we need to do some drawing afterwards. I cannot use a continue or a return because we actually need to do something afterwards. And I haven't found a way to write this code in another way. Why is this an error? What? Tile layer must have a what? Type tile layer must have a symbol.iterator method that returns an iterator. Sorry. Why is this an error? I'm gonna check the type again. Did I mess up? Tile layer. Tile layer. Where is it? Tile layer. Okay. We have a number. We have the tile layer. Objects never. We have the base layer. That's strange. I did not have this error previously. What's the issue? Return an iterator method. Why do you need that? Let me look at what I put actually in the utils in my original code base. Tile layer. Wait a minute. What? Maybe I'm gonna go to types. Here it shouldn't be any error. So okay, so there's something wrong with the typing here somehow. I'm gonna fix it later. For now, let's focus on getting things drawn. So in the case where the remainder is not equal to 0, that means we're still in the current line, in the current row. And that means we just need to increment the x position by the tile width to get to the next tile to draw. And then after doing this, we increment the number of drawn tiles. Now this might be more ideal to do it after drawing, but it doesn't matter. And then here we need to check if the tile equals 0, then we continue. We skip drawing. We consider it to be drawn, but we skip the drawing. The reason for this is that in the arena.json file, you have this, and 0 in this array corresponds to the absence of a tile, not the tile number 0, the frame number 0. But in Kaboom.js, the frame, the way frames are counted, starts with 0 and not 1. So that's why in the case we have an empty tile, as explained by the data array, So 0 for the data array. For tiled means that there is a no tiles, not the tiled 0. So that's why you need to skip over it here. And that's why when we're going to actually draw, by using right below, adding it to the map object that we've passed in, we're going to need to first use the sprite, tile set sprite. We haven't yet loaded this in our main.ts file. We're going to have to do this, but let's just continue on. We need the frame. So frame property. So as I told you earlier, sprite has a second optional param, which is an object that allows you to either specify the default animation or the specific frame you want to draw of your sprite. So here we're going to just take the tile minus 1. So tile here in this context in the data array, in a tiled tile layer is a, wait a minute. So I think I know why. I forgot something. Maybe not. It's not just layer, it's layer.data. That's why. Because it's the data property that has so this is the number. There's a number because it corresponds to this. It's called tile. I should have, for cleaner code, tile number. But can I type it here? I think it's better to just name it tile number. That way, I think it's going to make the code much clearer. Now, this is not just meant as a type. It's actually meant to describe what it is. It's not the tile itself. It's the number of the tile. So, yeah. So here, after having drawn the sprite for the position, we just can pass in as the second component, the pause component, and pass in the tile pause constant, which was the vector2 that we used to update the current tile position. And then finally, there's something that I like to add, which is the k.offScreen component. What happens is that when the player is off screen, not the player, the camera isn't looking at a game object, it will make sure to reduce the number of calculations or not render it at all, which will save on performance. But I am starting to have doubts if it does anything actually with just calling it like that. I see that you have this destroy true, but controls the behavior of an object when it goes out of view, but not much more. You can just like specify things here, destroy true. But really, I have noticed a performance difference, an insane performance difference compared to without it in a previous tutorial, which was my 7-hour platformer tutorial. In that, I realized that adding this would allow me to have like 60 frames per second instead of like 30 or even less. So that's something really to think about. I'm gonna keep it here, but test it out on your end. Try to see if you remove it or not, what happens. All right, now we need to import this tile set. So let's go to main.ts. And yeah, so the typing issue I had earlier on is non-existent because it was just me on my part that I forgot to add the .data. So that's why. Okay, so where is it? Okay, right below the fence. Let's import. Let's load actually. That's the proper terminology. I'm gonna load the file, the sprite. Let me just find it so I don't have to, so I can just copy paste it. And here again, we're gonna deal with slice X and slice Y. So here we're telling that there is, okay, if I remember, this was 6 frames in a row and 1 frame per row. So that means 31 frames per row and 22 frames per column. Sorry. Yeah, per column. And how I'd figure this out, you have your image here. This is the tile set. And if you count from there to the end of the image, there is 32 sprites. So if I click here, 31, actually 31. Or maybe it goes beyond. Let me just look at the code again. 31, exactly. So, and you can use tiled to help you with this. Here, when you select a frame, it gives you an ID. Somehow, something very strange is that when working in tiled, in the editor itself, tiles are calculated from 0. So numbered from 0. So this, the top upper tile, is 0 in tiled. But in the export, in the JSON export, the ID 0 corresponds to an absence of a tile, not a tile. So that's strange. But yeah, so if you count, if you go here, go to the end and consider that this is 0 based numbered, so it's 31 tiles instead of 0, 31 tiles in the per row. And here, if you go to the last, it's well, for that you have to count manually because it's numbered like that per row. So here you have to count 1, 2, 3, 4, 5. I'm not gonna count it, but you should find 22. So we have 22 here. All right, now I think we have done it. We have our function ready and set up. Now we're going to draw that tile. So back in main.js, where we initially had the layers of layers, what we're going to do is I'm going to write at the bottom, basically, at the absolute bottom. So yeah, it's becoming a bit a long logic to draw the map. It's the same logic that I've used in the previous tutorial, the Zelda-like, with some things modified, but basically the same logic. The reason I haven't really wrote it in a reusable fashion is because I'm not sure which part are actually reusable and which aren't. And it seems to be quite coupled with you kind of need to understand how to deal with it, how to read the file, which parts you need. But if you have any like way to design this drawing logic in a clean fashion, feel free to share. Maybe like send me an email with your GitHub or in the comments, tell me how you would do it. That would be nice. All right, so right below. So the way we wanted to do is that after having drawn all the decorations, we want to continue. The reason we want to continue is that we don't want to run what comes after, because for the current layer, the layer here, we had a decoration, we drawn it. Okay, so we don't need to run what comes after. Here, we're going to have an if statement. And we're going to check if the layer.type is equal to if the layer.type is equal to a tile layer. If it is, that means we can safely call the draw tile k.map and then pass in the layer, the current layer, and the tile width doesn't change. It's for the whole map. Tile height doesn't change. So we're finally using that from here. Oops, from here. Now that we have done this, yep, we should look at it and see if it has drawn everything. I'm starting to doubt that the typing here is even necessary. So, yeah, let's do it. All right, we have our map drawn, fully drawn. That looks nice. Now we have to work on the players themselves, so the ninja and the fighter. There's a bunch of stuff that we need to do. For example, you need to like really have, this time around I've really taken the time to remake a good to the best of my ability controller for the player, so that when you hit the various edge cases, when you hit, when you stop hitting, when you move around, etc. So we're gonna have to deal with a lot of animations, etc. So that's something that we're gonna do in hopefully soon. All right, so one thing before going and writing the code for the players, I forgot one thing. to actually have the boundaries drawn for the platform, the ground platform. So this is important because if we don't do this, when we will be placing our player, he will fall. They will fall to outside of the canvas, outside of the camera's viewport, and basically we won't have a game. So in order to do this, we're going to go here again, and right below, we're going to follow the exact same structure as the previous if statement, where we first check a couple of things. The first thing that we check is, first of all, if the layer dot name is equal to the name of the layer itself, which is the spawn points with a capital P. Here it is. And the second condition we need to check is wherever or not the layer type is actually an object group as well. After having done that, we are ready to write the code for it inside. So basically here, the same exact structure, another for loop. Oops. In that for loop, we'll have object of layer.objects. Once this is done, we are simply going to add to the map the objects. So the way I've done it here is, let me just look it up. Kind of forgot how I did it. Okay, so basically we need to change the orders, I think, because this needs to be drawn. It doesn't matter whatever or not if you put this here or this here. So it doesn't really matter, and because of that, you can just leave it here. And what we're going to do inside of it is simply have the call to map. So add this map.add. I'm gonna add as a child to the map a game object, which is going to just contain 3 components, the area components, and this is where the shape property of the area component comes into play. I've told you earlier on in the tutorial, we probably don't remember because it's been a couple of hours now, is that the area component by default, if you just leave it as is, just use it without passing in any arguments, it will create a hitbox for your player, or not randomly, but that roughly follows the outline of the sprite of that game object. Now, if you want more control, you use this. You pass in an object with a shape, and then you specify the shape. To do so, you are going to use the new keyword, and then we're going to use the rect constructor offered by Kaboom to create this rectangle that is going to be the hitbox for the boundaries. So here, just one thing I want to also show you is that here, press F1 to enter debug mode. I think I have mentioned this earlier on. I'm not sure anymore, but just in case, I thought I would mention it again because we're going to see a new rectangle appear here that is going to be the boundaries for the ground platform. So here, what are the properties that we need? Well, here we the rect constructor takes 3 params. The first one is a vector2. This vector2 specifies the position relative to the game object in which this component is used. So for example, if this game object that is created as a child of map is positioned at 0, 0, if you were to add 1, 1, it would add 1 pixel to the right and 1 pixel down. But because we want our shape here, our rectangle, to be exactly the area, so the hitbox, we want it to be exactly where the game object is, we can just pass 0. That means that this positioning is relative to the game object that uses this component, and if you don't want to have any difference whatsoever, you would simply use pass in 0 here. It's basically the same thing as the thing we did with the camera, where you could just specify one value for both x and y coordinates. So here, 0. All right, so now the second param of the rectangle constructor is basically the width and the height. And we're going to get this from the tiled export JSON file, the arena.json. And it is available in the object basically here. that you can see in the, for example, here in this layer, boundaries, and then you have width, and do you have height as well. So that's how we are able to figure this out, because we need to draw a hitbox that has a certain width and height that covers the whole ground, basically ground platform. Now you could have said that we could have, instead of creating a separate layer and drawing a huge rectangle, we could have drawn a hitbox for each of those tiles, but this is where it's less performant in Kaboom.js to do so. So if you create too many areas for tiles, what will happen is that Kaboom has to keep track and calculate collisions between those tiles, and this will significantly affect performance. That's why I like separating them out, separating the tiles from the hitbox, the area for that tile, so I can combine them and just draw one shape instead of multiple squares that are stuck together, which will cause the collision calculation logic of Kaboom.js to trigger, I guess. Now, what I'm going to do next is use the positional component, k.pause, and in that, I'm going to simply do the exact same thing we did, specify the object x and y coordinates. And finally, this is new. We're going to use the body component. Now, what does the body component do? It allows your game object that uses that component to be affected by gravity. We haven't yet defined any gravity, but not only gravity, but actually, that's not true. First, yes, it is going to make your game object affected by gravity, but also collisions, basically. It's not just for gravity. And you can pass in an object with the property is static to basically tell Kaboom.js that this specific game object that uses the body component is going to be a solid that is affected by no gravity, and when colliding with another body will not move. So basically this is ideal for platforms. So you have to specify this to being true for it to work. And once this is done, I think we're ready. We can look at the output. So here, to see nothing has visually changed. So to really see what happened, you need to press F1 and whoops, it's not appearing. Maybe I did it wrong. I'm gonna do this. Maybe I forgot to save. Map add spawn points. Maybe the name of the layer is wrong. No, it's the correct one. Okay, that's strange. We have map add. We added the area. So one of the issues with using tile here is that for some reason it's not enough to. There is an offset somehow when you're drawing an object with a width and height. And I don't understand why this offset exists, but basically you need to increase the tile height. Not increase that. You need to add the tile height to the y coordinates so that the hitbox will. What? It's not working at all. That's strange. Okay. Well, in that case, object group, spawn points. Maybe I did a mistake. Oh, you have to continue. You have to continue here, but it's not for that reason. It should be working. We have the add function, object width, object height. I see. I made a typo mistake here. Nam isn't its name. That's why I should be careful. All right. It's still not working. Even if I refresh, I used the wrong layer name. It's not spawn points, it's boundaries. Spawn points is for the players. That's why. Now if I go and I look, yeah, you can see it here. And I just wanted to explain as well. So if I'm just going to remove the console.log. For some reason, I need to add this tile height value to the y coordinate. Otherwise, what happens is if I go here, it puts the thing a bit upward, and I do not understand why. Let's try something out. Maybe for the, let's try using the anchor component, k.anchor. And instead of top left, what happens if we do bottom left instead? Does this work? No, it's even worse. Okay, if it's not bottom left, what about center? Does it work? Let's look. Even worse. Yeah, I don't think I have a solution for this. So if you understand why we need to add this offset when working with tiled, and it seems to be like only for this tiled height, not width, that we need to add the offsets to for it to fit. So that's very strange. Anyway, yeah, I would like to know why, but let's move on. And maybe if you have time to think about it and you have found a solution, feel free to share in the comments. Okay, so in order to really finish everything, I'm going to also, so the ordering here doesn't matter except for the last one. So I can just put it here, and because the ordering is decided by the layers array. The layers array here. The reason for this is because the layers are put in a certain order. This order respects this. So this is first, this is second, this is third, this is fourth. So no matter when you put the if statements, it's not going to change much. So the continue here is mostly for avoiding unnecessary calculations. So if you know that you are in this layer and you have drawn it, then just continue to the next layer instead of checking the if here and here as well. So here I'm going to set the code up for the spawn points layer as well. So spawn points layer is where we're going to spawn our two players, and this is why it wasn't working previously. The code it wasn't what I expected. So it's an object group layer as well, and let's keep it like that. I'm just going to write a to-do comment and leave it at that. Now, one thing I want to check is regarding this. Can we remove this without any repercussion? Yep, it seems to be. It seems that the typing then for this wasn't really necessary. Was it in the utils tiled tile layer? So yeah, it seems this was not necessary, but before removing it, I'm going to keep it. And if there is any issues further down the line, I think that was some leftover code that I forgot to remove, and I needed to type this for it to work. And because the situation is no longer needed we no longer need this, then I just forgot to remove it and put the for loop like it was, like the conventional for loop. All right, now I want you to create in the source folder a entities folder. And in this entities folder, what we're going to do is create three files. The first one is I'm going to call it fighter.ts, ninja.ts, and samurai.ts as well. So the way I structured the code is basically fighter and will contain general logic that applies to both the ninja and the samurai. And for specific logic, we're going to write them in each of those. So ninja and samurai. So let's first start with maybe the samurai. And then as we find reusable code, we're going to write code in fighter.ts. But before moving on, just to have everything we need, I'm going to create another folder. I'm going to call it the UI folder. And in that UI folder, I'm simply going to create a new file. I'm going to call it healthbar.ts, which is basically almost the only UI element in this game. So it's not a UI heavy game. So let's jump right into fighter.ts, samurai.ts, and let's start. So the way I'm going to proceed here with writing logic for the players, etc., I'm not going to use object-oriented. I'm going to use a mix, I won't be using the class keyword. So in the previous tutorial, I've made one tutorial, the platformer tutorial that uses classes, and the Zelda tutorial that doesn't use classes. And both of those approaches have strengths, and weaknesses. And in here, I'm gonna try to combine both approaches. So let's go. So here I'm gonna create a function. I'm going to call it make samurai. And what this is going to be, it's basically going to act as a constructor. The same, yeah, basically constructor. And the params we're going to need for this are 3. So we need 3 things. We need the context, of course, the Kaboom context. We need to pass it, Kaboom CTX. Now here I'm going to fix the issue by clicking on the light bulb, add import from Kaboom. The second thing is the parent game object, because remember, we are appending this to every game object we create are appended to the map, because the players are on the map, basically. The only thing that aren't is I think the UI. The UI is the only elements that are just drawn directly on the canvas as their own game object and not as childs of any other game object. Here in Kaboom, here we need to fix the import statement. So I'm going to import Kaboom object here. And finally, the third param I'm going to need is, of course, the position. Where do you want to place the ninja, the samurai here? So here, position, I'm going to call it vector2. And again, we need to import those types from Kaboom.js because those are Kaboom specific types. Okay, I'm just going to do it manually. Vector2. And I'm going to close this off to have more space. All right, what comes next then? Well, this is where I'm going to create a game object variable, and it's going to hold the game object created. So I'm going to call the add function that is going to create the samurai. And here we're going to pass all the components we need. So the first component we need is the sprite component with the samurai sprite. Now this is not yet imported, so I'll have to do that. And I'm going to do it right now. So go back to main. Where is it? Main. And then from main, I'm going to just copy and paste it and then go over it, because I think manually coding this is going to be tedious and there isn't much value. I just want to cover a few concepts though that are I assume to be very important, and I've received questions about them. So let's do it right below this line in main.ts. So here's the code for importing the samurai asset and how we slice it. So just to go over it, let's open up the entities folder in the assets folder and the samurai.png file. So those are the frames. Like I said, we have the frames in Kaboom.js are numbered from 0 onwards. So 0 based index. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's not because there is no image here that there is not a frame, considered a frame. Because the way Kaboom deals with it, it takes your images and just make a couple of slices. So even though there is nothing here, it's still considered as a frame. This is a frame, this is a frame, and this is a frame. So by having this logic where you see that you have 1, 2, 3, 4, 5, 6, 7, 8 frames in a row, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 frames in a column, you can specify the values here of slice X and slice Y. So slice X, number of frames you want in a row, and slice Y is the number of frames you want in a column. And with this information, you have everything you need to find the animations, to define your animation. Idle from 32 to 39. And the way I did this was to just count 0, 1, 2, 3. Okay, this is, for example, idle is from 32, 34, 32, 33, 34, 35, 36, 37, 38, 39. And this is what I put in the 2. And I want a certain animation to loop. For example, for the idle animation, I want it to loop, and the run animation. because those animation cannot really complete. They are only canceled when the player presses some other button. The attack animation, though, is a specific animation that does finish. So it doesn't run forever. Same for the death animation, the hit animation, and for the jump and fall animation, it's infinite basically as well. So you only cancel them and replaces them with one of the other animations. So just to give you some time here, pause here to write this out. Here you go. And then here you go. Optionally as well, there is the repo in the description. So you can just go to the file and just copy it. All right. Hit save on main.ts if you haven't. Let's go back to the samurai.ts file. And in that file, I'm going to write the rest of the logic for creating our game object. Here, the default anim, of course, is going to be the idle animation. And now here, we're going to use the positional component to position our character. We're going to use the area component to create our hitbox for our character. So the shape here, the shape is going to be a rectangle. It's going to represent the area in which the player can receive a hit. So here, rectangle, k.vector2 for the positioning, which is relative to the game object. Now this looks a bit weird, so thanks for the formatting, Prettier. And now here, we are going to simply have a rectangle that is of 20 by 40, and there's 0 offset to have here, so 0. And then one other property that the area component comes with is the ability to use this collision ignore. Collision ignore allows you to put tags of game objects so that the collisions with it will be ignored. Why this is useful is we don't want the ninja to be able to jump on the samurai and the samurai to be able to jump on or push the ninja. We want to only make the ninja or the samurai vulnerable to sword attacks. So here I'm going to pass the name ninja, which is an arbitrary tag that I've decided to add here to give to the ninja. It's not yet written. I'm going to add it to the logic. But for example, for the samurai, I'm going to already add the tag. So a way to add a tag is basically a unique identifier for a game object. You can just add it by passing in a string inside of your list of game components. And this will allow you to detect, give basically a game object ID to that game object. Now, this is mostly used not only for single components, but for groups as well, because there is the get function in Kaboom.js that allows you to get all tags of a given, to get all game object, to get all game objects that have the same tag, and it returns always an array. So that's why if you want to use it only for a single object, what you do is you simply call it with this and just take the first element. So once this is done, I'm going to add some other components. I want to draw the ninja from the center instead of the top left corner. This is going to make our lives much easier. I want to make the player susceptible to gravity and physics. So I'm going to add the k.body. I'm also going to add the health component, which allows us to keep track of the health of the player. It's basically code you don't have to write yourself. I'm going to give him 10 points. And Kaboom comes with the hurt function and heal function as well to reduce or increase the value of the health. So this is some nice code already made for you. This is why I think Kaboom.js is really like high level at the same time. So it's not just a game framework. It offers certain conveniences, as you have seen here, to make your games really quickly. Now I could have just created a singleton or a class and kept the state there, but you know, it's there, so it's easy. All right. And also one thing we need is the opacity component. This is going to be useful later on because we're going to make the ninja and the samurai blink when they get hit so that the players can really see that, hey, I got hit. So some visual feedback of some sort. Now that we have this, right below this samurai, we're going to create an object. So the way to store data and handle state in Kaboom.js can be done through this, where in your arrays of components, you pass in an object with the properties, and those properties are going to be the properties of your game object. So you're going to be able to access them by simply doing game object dot the name of the property you put there, here. There are default properties as well, coming from whatever or not you use certain components. So this is very a nice thing that allows you basically to bypass object-oriented programming in most cases. Here we're going to define something later on, so I'm going to keep it empty for now. And finally, I'm going to return two things. I'm going to return the game object itself. So in an object, I'm going to return the game object, and I'm going to return a method I'm going to call setControls. And here, this method is something I'm going to be able to call. For now, let's keep it at to do, and let's leave it as is. As for one thing as well is the direction the player is going to be facing. So, yeah, I want to keep track of that, and the way you would do this is, well, for now, it's not important, but one player is going to be facing right, so the samurai is going to be facing right, the ninja is going to be facing left. So that's that. And later on, we're going to make right logic to make sure that this happens. All right, so we have everything here. I think we can start drawing in the map and then adjust from then on. So here in the to-do I left here in the spawn points in main.ts, what we're going to do is I'm going to first go to a new line, and then here I'm going to try to make the following. So if we need a for loop for const object of objects of layer dot objects. So for all for basically all object, we're gonna iterate through all the objects of this layer. If object dot name is equal to player dash one, we're going to run some logic and then continue. Whoops. And if the object dot name equal player 2, or basically we don't need the second one, but just to be like, you would probably need to convert this to a switch case statement if you have many entities, but for now I think we could either remove that, or let's keep it just to make things clear, and also add a continue. It doesn't serve a purpose, but in case you want to add other, and basically you will have remove this and make a switch case statement. I think that would be best. All right. So in main.ts, what I'm going to do next is, all right. Yeah, actually, I actually used a switch case statement in my original code. So let's just do that as well. So just to be like to fit in, and it was a good choice, I think, here. So object.name, and then the case 1. If the player dash 1, then to do, and then we break, and then case dot player 2 to do break. Those breaks are really important because in JavaScript and TypeScript as well, if this case is valid, so if it is the actual case, so if object name is equal to player 1, it's going to run this, and if there were no break, it will move on to the next, and the next logic here. So that's why it's important to break always in a switch case statement in JavaScript and TypeScript. All right, so this is done. And I think outside the for loop, we just need to continue so that we don't need to run this logic. All right. Okay, so now what I'm going to do is I'm going to create right under the map a const entities, and it's going to hold the game object for player 1, initially it's null, and player 2. The reason I want to store this reference to this is so I don't have to do global state management. So I can keep those game object for later on because we're going to do some logic after the drawing here. And yeah, so that's the main reason. Here, I'm going to simply do entities dot player 1 equal, and then I'm going to call make samurai. It should be imported. So if you go to the top, make samurai. And then in there, I'm going to pass whatever is needed. K, the parent is the map. The position is object, it's k.vector2, object x, oops, object y, and then the position, yeah, after the position, I think that's it. We have the 3. And then you'll see that we have a squiggly lines. And the reason for this is that it does not want to allow you to assign, TypeScript does not want to let you assign something that has both a game object and a set controls to something that it thinks should be null. And the way to get around this is that you need to specify typing here. Now, there isn't a type that will describe what we're returning here, really. So that's why I think we need to create our own type. And that type, I'm just going to export it, and I'm going to call it entity. So what this type will do is it will simply describe what we return here as a type. So it's an object with the game object property, which is of the type game object, and a function. So for now, entity, what is going to contain is basically the game object field, where the game object type that comes from Kaboom. I'm going to import it from Kaboom, so it should be at the top. And the second property is the set, what's the name? I forgot. Set controls function. So I'm going to just write the name of the function and then specify that it's a function that returns void. Doesn't return anything. And then yeah, it doesn't take any arguments. So this is how you would type it. Now in main.ts, I would simply tell TypeScript that, hey, the player 1 property can either be, so the way you type an object like that is you would have the brackets here. You would put a square bracket here that seems like an array, but it's not an array. You're going to write key and then type in string. So here you're specifying that the key here is going to be always of the type string, and the value is going to be either an entity that I'm going to import from my previous typing that I just created, and it can either be entity or it can be null. Or it can be null, but it could be both. Could be entity or null because this is a union. So be careful with this. The thing I've explained regarding unions is still valid, even though I don't think we have a use for this type. So it's a this or that or both, unless you make sure to have the never thing here that you add to each of those so that they are mutually exclusive. All right, so we have this. Now TypeScript should be happy, and he is. So now I'm gonna, yeah, for this, the player 2 is basically the ninja, so let's keep it that way. Now for the Ninja, the structure of the code is going to be the same, and I'm going to copy and paste it and just go over it so to go faster basically. And here I'm just going to copy this function signature, and I'm not going to copy everything at once. Let's import everything. We need to add all missing imports. Yes, I should have used this earlier on. And then what we're going to need now is I'm going to take this and I'm going to paste it. I'm going to remove this. This is something that we're going to have later on. I'm just going to put 10 for now. And of course, I'm going to put the empty game brackets, game object, empty JavaScript object, sorry. All right, we have something clean here. I'm going to go over this. So basically the same pattern, game object, certain components. Here we need to import the animations for the Ninja. Same logic as the Samurai, just the frames numbering might be different. So I'm just going to take this, go to main. I'm going to copy and paste it. Then I don't think I need to go over it. Maybe just show it to you so you can copy it. But the logic is the same. The sprite sheet is different though. So the numbers of rows and columns are different. But here it is. Anims, idle, etc. Play with those values and you're going to notice, you're going to learn a lot by doing this, by experimenting, just playing, like create animations, define another animation, call it test, and do from 0 to 1 and see what happens and play it, etc. All right, so copy this and this, and finally this. All right, I think you can pause in all those cases. Again, just a reminder, you can just go to the description of this video, hopefully, and find the source code. So you can just copy it from there. All right, one thing for the Ninja. Okay, the Samurai here, the Ninja tag, everything is added. Position. Here, there's a slight difference. The rectangle is going to be pushed slightly 6 pixels down, down. 6 pixel downs. Just so that because the Ninja sprite is a bit taller than the Samurai sprite, and therefore we want if you don't do that, the Ninja will look like it's sinking in the floor, because the only thing that keeps the Ninja and the Samurai, the players, from going to the ground is their hitboxes. So just to maybe illustrate this in a moment, I'm just gonna leave it as is for now. So here again, same thing. And then of course what is returned is basically the same. I'm gonna just copy it directly from here. And this gives you a good base from which you can add methods and stuff like that. So it's like object-oriented programming, but without calling classes, without using the class keyword. But at this point, really, like, it's up to you. You might think that it's best to just have the class and that's it. Just have this everywhere. All right, now let's look at let's go back to main, write the last bit of logic here, but instead of Samurai, it's going to be Ninja. Click on this to import it. Don't forget to put this to 2 instead of 1. And I think we have everything we need. Let's look at the result. All right. The reason the players are here is because we haven't set up the gravity, and we need to do that. Fortunately, setting up gravity in Kaboom.js is very simple. It's a single line of code. What you need to do is to go to main.ts, and as the first line of the area scene, yeah, it needs to be set by scene though. You're going to call the k.setGravity, and the value I'm going to use for the gravity force, I don't remember what it was, so I need to look it up. It was 2000. So play around with those values, see what it looks like, and pick a gravity that looks good. But for now, it's not. Maybe you'll have to first implement the controls to really get a feel for it. All right, we have the samurai, we have the ninja, everything's going fine. Here you can see the boxes. You can see how the box here is. And now let me just go to the samurai, the ninja. So if I try to remove the 6 value here and just keep 0, you're gonna see the following. So you see the character is sinking a bit because the rectangle is placed a bit too above. So that's why I put 6 here, because this is what looked good. I'm gonna save. All right, so now we have our players, we have gravity. So what is left is really player controls and all the intricacies and details that comes with it. So this is where the fighters.ts file come in. There is a lot of shared logic between the two, the ninja and the samurai. And this is where I've decided to write it. So in the fighter, first we're going to create an object that is going to be used for both. It's going to contain properties that are both used by the ninja and samurai. So fighter props, I'm going to call it fighter props. It's going to be equal to an object. This is where I'm going to define a speed value, going to be 200, a direction, whenever or not the player is facing left or right, I'm going to put it to null for now. I'm going to define a isDead boolean set to false. I'm going to define a isCooldown active. So this is to prevent spamming. So when one player attacks with the sword, we want to have a small cooldown before they can attack again. So this is going to be set to false. Max HP, this is important. It's the maximum HP. It's going to be 10 for both. Previous HP, this is also important. This is how we're going to deal with a health bar that gradually diminishes. We need to know what was the previous HP value for this to work properly. And then we have the previous height. I think I never used that one though. Let me check. I think this property might not be useful. Yeah, it's useless. Yeah, there's no need for that. Just gonna remove it also in my original code base. Yeah, there's a lot of things like that where you forgot to remove certain things. So these are the properties we're gonna need for this game. Now we need to type this. Or do we? I think for now there's no need to type it, but later on we will probably have to type it. So in our Ninja code, you see the empty object. The reason I kept it empty is because this is what we're gonna just add the fighter props here. So those are the shared properties I want. Now the way I did it in my original code base was to create an object and then use the spread operator to spread them inside of this object. The reason for this is that if later on you want to add other properties that are specific to the Ninja, you can just add them here. So here I'm gonna just import that from fighter, save. I'm gonna just copy and paste the exact same code. I'm gonna do it for the samurai here. So I'm gonna remove this, do it for the samurai here, import that, save. Everything should be all right. Now here in the health here, I'm gonna actually use the fighter props as well. Health, previous HP, max HP. I think that was the one I used. Max HP to set initially the max HP to be the health the health at the beginning of the fight. Same thing here. Instead of 10, just gonna use the fighter props and pass in the max HP. All right. Now in fighter, this is where things are gonna get complicated. We're gonna need to handle the player controls. So I'm gonna create a function. I'm gonna call it set fighter controls. And the thing I want to pass here is 3 things. I want the context. So like you're used to right now, passing the Kaboom context. We want the fighter, which is the game object itself, not the entity, just the game object. And then the keys. So those are the controls. And here, instead of like creating a separate type for this, I just created an object. I typed it using an object. So this object, the keys object, is going to contain 4 keys, and they're all typed as string. And I'm going to refer to them as left, right, up, and down. So, left, right, up, and then down. Now we have everything. We need to, of course, import all missing imports. And we should be good to go. All right, so what we need inside to do this. So the reason I'm saying this is going to be complicated is because it's actually the most complex part of the project, not that it is like really hard. So here, I'm going to create a onKeyDown constant listener, and I'm going to hold a reference to the onKeyDown event listener. So in Kaboom.js, you can listen on keys by using the onKeyDown function and pass in a function within that function. So, and in that function, you can have access to the key, the current key that is being down. So here the param here is going to be the key. I'm going to save this. I'm going to hit enter. And here is the logic we're going to write. So this onKeyDown listener is only going to take care of movement that is to the right or to the left. For jumping and attacking, we don't want to listen on when the key is down, but only when the key is pressed, because onKeyDown is basically holding the key down. So it makes sense for movement, left and right, but not for jumping. Well, actually for jumping as well. So I think jumping, no, not for jumping as well. So jumping is a press, like an attack. All right. So here the logic is going to be simple. First, I'm going to have a first if statement. This if statement is going to check. So since we have access to the game object, we can have access to the cur_anim function that's offered by Kaboom that allows us to verify which animation is currently playing. So if the animation that is currently playing is attack, we want to return early. The reason we want to return early is that when the player attacks and launches an attack animation, we don't want them to be able to move until the attack is over. The reason for this is, there's many reasons, but actually the main one that is for this project is simply that the animations that I have do not work well for a person that attacks while moving. They don't look good. All the attacks are really in place. If you look at this, maybe for the samurai it's less true, but for the ninja, the way he attacks is really like in place. It looks like, and also for gameplay, it might. Well, for gameplay, it's debatable from a design perspective. So, but for like the actual sprite sheets that I have, I think it looked less good. All right, so now I'm gonna have another if statement right below. So when the current animation is the attack animation, remember those animations are defined in main.ts when we imported these sprites, when we loaded them. So for fighter current anim equal attack. So if this animation is currently playing, we return early. So that means none of the code that comes after it will run. So now, considering that this is not a case, we're gonna have two cases: when the key is left and when the key is right. So if keys, so here I think I'm gonna create an enum. Is it an enum I want to create? Never mind. It's typed here. So if key dot left, keys dot left, that means the player wants to move left. So if the player wants to move left, we can check this by comparing if the key that is currently down is the same as the keys dot left that is passed to the set fighter controls. The reason for that is, for example, for the samurai and ninja, they have different control schemes. For the samurai, it's WASD. For the ninja is arrow keys. Now, one thing I'm not sure with Kaboom.js is whenever or not the WASD is keyboard dependent. So is it really WASD, the actual letters, or the position? Because if you have a AZERTY keyboard, then it might not work. So if you have an AZERTY keyboard or any other keyboard that isn't the standard US one, tell me, do WASD work on your end, or you have to change them to the specific keys that you use? All right. So key equal keys dot left, and let's write right below it another if statement. If dot key equal keys dot right. If you see this getting out of hand, so let's say you want to expand the game further along, transform this into a switch case statement. But for now, I don't think it's necessary. We could do it, but yeah. Okay, what happens here? Well, when the fighter, when the player with a specific, okay, so when this specific fighter press the left key, we want to flip X to being true. That means we want the player to face the left side. Flip X is going to flip the character as like a mirror, the sprite. So you don't have to have separate animations for left and right facing. So that saves us a lot. So if here you see, this is only looking to the right, same thing here. So by only flipping, we don't need to have like twice the numbers of animations for each side. So here, because the ninja and the samurai sprites are facing by default to the right, by flipping them through the x-axis, we can make them face left. And then here, we're going to use the move function. This is a function provided by Kaboom for every game object that has the body component, I think. So here, you specify fighter.speed. Remember, this was a fighter props that I passed here. And every prop that you passed in this bracket, this object, is available as a property of the game object itself. So minus fighter.speed is going to move the player to the left from the x-axis. For the y-axis, we don't want to move in the y-axis, so 0. Now, here we're going to set the direction. This is going to be useful later on because both fighters are going to be at each end of the arena, and one of them is going to face left and one of them is going to face right. But also it's good to know when to flip, etc. So that's why I decided to keep the direction as a value here, as a value can have. Now here you don't have to do it at this stage, but in my original code base I just created an enum. So let's do it. An enum is just a way to have values associated I don't know what the proper terminology for it is, but basically it will prevent you from making errors while typing out strings. So instead of typing direction equal left as a string, I'm going to create an enum that I'm going to call export type enum directions. And this enum is going to contain the left key, which is going to basically be left, and the right key, which is going to be right. We don't need the equal sign. And we also don't need this. And did I make... I don't remember the syntax. Let me look at it. Okay, so it's capitalized. I put it in my original code base. So left, right, and then using comma separate values, left and right. And yeah, in the end, it wasn't used outside of very few instances. That's why if you don't feel like it, you can just decide to not do it. Here I'm gonna import that. So directions here. And that's basically it for this. Oh, we need to, of course, play animations. So right below it, we're gonna have another if statement. So if the fighter.current animation is not equal to run, the run animation, and we need to add another condition that the fighter current animation is not equal to jump, only then we will play the run animation. So the reason for this, the reason we want to make sure that the run animation is not already running is because if you do that, and since the on key down can be ran multiple times in very short instances, then if you run an animation like running and you replay it again while it's actually running, then it's going to start back from 0, and that means that your character will glitch out because the animation never completes, basically never progresses to the next frames. And the reason I want this is because if you move to the left while jumping, we want to display the jump animation and not the run animation. Later on, we will write logic for it to check if the player is on the ground or not, which will allow us to, know when to play the jump animation, etc. So here it is. Here's the reasoning. And finally, we can return early. And you know what? Just to make it look nice, I think let's do it. Let's use a switch case statement. And here I'm gonna just put it key, and then I'm just gonna put case equal keys dot left, and then instead of return, it's going to be a break, and then the case here is going to be keys dot right, and I'm gonna remove that, and I'm gonna put a break again, and then I'm gonna put the default, which is required here, even though you don't have the default case. Now for the right, it's going to be the exact same logic, just with a few differences. So here are the only actual line that changes is this, whether or not to flip the player, and the direction in which it's going, and this as well. So 3 lines. So the only thing left is this. So if you want to really make reusable, never mind, it's not going to work, and it's not worth it anyway. So yeah, one thing I don't like about the switch case statement is that it makes things look too compact. So this might be tougher to read for someone. But yeah, so let's keep it that way for this project, and yeah, you can do whatever you wish. Anyway, the reason I'm storing this as an on key down listener constant here is that later on we're going to cancel those when the player dies. One of the player dies, we cancel those so that that player that died cannot no longer move or do anything. All right, now it's time for the second event listener. I'm going to call it const on key release listener. And this on key release event listener is going to use the k.onKeyPress. Again, same structure where we pass in a function, pass in the key here, and then we're simply going to have a single if statement. And this if statement is going to check whether or not, if the key equal keys dot left or end, or I think, or yeah. If either the left key is pressed, so or the key the right key is pressed, so either those two cases, and two things: that the current animation is not idle and the current animation is not an attack. So I'm gonna paste this just to go faster. Let's just close brackets. All right. So what does this do? So either that or that. Do we actually need? Yeah, we actually need either one of them, or both of them, to be released after being down for this logic to continue. So if the fighter current anim is not idle, so the idle animation is not playing, and we're not in an attack, then we will revert back to the idle animation playing. And because it's only a single line, we don't need to use brackets. Oops. And that's that. All right. And now the last listener we need to is the on key press listener. So this is for jumping and attacking. All right. So the reason I have this on key release listener is that when you run, there isn't the animation never stops by itself. It doesn't have an end. So the way to just stop it is to check, okay, the key left or the right key was released and the idle animation is not currently playing, so we can play it, and we aren't in the middle of an attack, so that means it's the perfect time to play the idle animation because the player basically has stopped all actions basically. And for the jumping anyway, the way it works is it will cancel any idle animation that is currently being played and just replace it. So that covers everything we need. All right, now const on key press listener. This is the last one. Listener, which is, oh, I made a mistake. I wrote on key press instead of on key release. I think you might have caught that before me. All right, here on key press, same structure. Pass in the key, of course. And then we can continue writing our code. So here we're gonna have an if statement and another if statement. Here there's I think we have a lot of logic. Not that much, but yeah. Okay, so let's start slowly. An if statement where we're going to first make sure that the the up key is being pressed. If the up key is being pressed, we need to check for another condition. We need to check to make sure that the player is on the ground. And how do you do this? Well, Kaboom.js offers you the isGrounded method on your game object if you, of course, have a body component attached to it. I don't think it will work if you don't have the body component. And then finally, you want to check if the fighter.current animation is not jump. Not jump. And then in that case, we're going to do two things. We're going to actually make the player jump. And one cool thing with Kaboom.js is that it offers you a ready-made method that you can just called jump that will do just that. Jump your character. Make your character jump. So you don't have to write any extra code for this. And then you have fighter.play to play the jump animation. And now that's it. And here we could write a continue statement or a break or return. Yep. Let me make sure. I think we can, return early so that the rest of the logic doesn't collapse, basically. That doesn't run unnecessarily. All right, so here I'm gonna have another if statement. I'm gonna check. I'm gonna write this here so it can be clearly visible, and the YouTube player hopefully will not hide the code. So here, keys.down, and then so now what we're doing is we're trying to write the logic for an attack. So to attack in this game, you press the down key. So that way, like, the controls are pretty compact. You don't have to have like a space key or another key, and both player can use the same keyboard and play together pretty easily. All right, in that case, we need two things. We need to first make sure that the key being pressed is down, the down key, and that the cooldown is not active. If the cooldown is active, then we will not allow it, the attack to occur. So fighter is cooldown active, a bank sign to put it to say that we don't want it to be true. All right. Yeah. So here, as soon as we enter this, that means that is cooldown active is actually false. With the bank sign, it reverses, so it's true. That means we pass inside of it. Here, this if statement. I'm gonna set the is cooldown active to being true, and then I'm gonna use the wait function from Kaboom. It's an easier function to use than set timeout. Basically, you put in as the first param the timing. So after 0.7 seconds, you want to run the function that is passed as the second param. Here, we just want the fighter dot. We don't just want to remove the cooldown. So is cooldown active is going to become false again after 0.7 seconds. All right. Now it's time to actually write the logic for the attack. And the way we're going to do it, the way attacks works, is that you play the attack animation, and then you create a hitbox in area that is going to then collide if the samurai is close enough with this, if the other player is close enough and they collide with that box that represents the attack hitbox, then they take damage. Otherwise, they don't. So here to do that, I'm just going to create a function, a small function that is going to be really only used here. So that's why I'm not putting it elsewhere. That is going to be called update hitbox, and it's not even a pure function. That means that we're taking a lot of things from outside of its scope, I think. Yeah. So maybe for this function, you could take as a convention to just write them as const equal arrow functions like that. Whoops, I made a huge mistake. Could write it this way. Might look nicer and less out of place. But this is just a personal taste, and yeah, it's just a logic that might not be shared by someone else. So here, an object. The hitbox position is going to take depending on whether or not the player is attacking from to the left or to the right. This is why the direction is very important, the direction property. So we can know where to draw that hitbox, either to the left or to the right. So now what I'm going to do is have a right property, left property, k dot vector 2. Whoops. And then here within, I'm just going to pass the following. So for the left side, the value I found to be good for where to place the hitbox is taking the position of the fighter at the x coordinate and subtracting 50 pixels. So it's going to be to the left and keeping the same y position. As for the right attack, it's going to be basically the same thing, but we increase by 50 pixels. All right. Now that this is done, we can return that hitbox. And the reason I'm calling it, actually, you know what? It seems that it's useless. It's useless in the sense that, yeah, it's a way to have some like reusable, something reusable, because if you call the position, wait a minute, I think it might not be necessary. You could just, well, that's strange. And do we need this at all? Yeah, we need it. We need it. Okay, we need it because this fighter.pos.x. If we were to just store it as a constant and put it outside, it's going to be the position at the instant that this code was ran, and not an updated version. If you call it again and again, it's going to always give you the updated version of the positions. So that's why we need it. So I have created the update hitbox function, and then here const attack hitbox. This is where we're going to create the hitbox. The reason here I'm not creating it as a child and just as an independent game object is because you cannot really I have trouble deleting. I think you cannot delete a child object without deleting the parent. That's why we need it to be separate, because we want this hitbox to be destroyed after the attack is done. And we need to keep all the other elements like the players, etc. on. We cannot afford to destroy them. So here I'm just gonna copy and paste the code to go faster. And I'm gonna cover it. So here, update hitbox position. I made a mistake in the name of the function I wanted to create. So update hitbox. Oh, I forgot to return the updated hitbox position depending on the fighter direction. Was it that? Or yeah. Now here we have an error. It's a TypeScript error. Element implicitly has any type because expression of type any can't be used to index type left. No. TypeScript requires us to type this, so we really know what it is, etc. So to type this, what you do, add the colon, do the exact same thing, brackets, specify that the key can only be a string and that the value can only be a vector 2. And now this can be imported. You need to import it from Kaboom. Save everything. Look at the top, it should appear here. If you go back, everything should be no errors here. So now let's cover this. So the updated hitbox, what it does, it calculates the updated hitbox depending on the direction, either left or right. And then here we can even be more precise. For the typing, you could say, okay, it could be like directions.left or directions.right and nothing else. Why does it not allow? An index version cannot be a type literal or generic type. Consider using a mapped object type instead. Okay, in that case, it doesn't want to allow me. What if I just do left? Does it allow me? Okay, it doesn't. So use a map thing. Okay, let's keep it as strings, not that important. I created a constant called attack hitbox. I'm going to use it later on to update the position. It's a game object that contains the following 3 components. The first one is the rectangle, the shape. It's a 50 by 50 pixel rectangle. It's drawn from the center, and the position is pulled from the update hitbox function here. Now this is just for the first time you attack, for while the attack goes, but because you can still move while attacking, in the sense that you could jump and attack, and while you fall, you're effectively moving. That's why we need to create an update loop that will update the hitbox position. That's why we need this reference to this game object later on, not now. All right, so here, what comes after is I'm going to write a, I think that would be better to just put it, to just do that right now instead of waiting. So what I'm going to do is have this attack update ref. It uses the onUpdate function provided by Kaboom. This allows you to hook into the update loop. So register an event that runs every frame, so 60 times per second. And it will update the position of the attack hitbox by accessing the pause property, because we have used the pause component, and just calling this again, and it will give you according to the new fighter position, basically. Hope that was clear. Now, once this is done, is there a reason yeah, and then might as well create, might as well write the logic to when to destroy that update ref. So this event loop, that's why I stored it here, and also the hitbox. So what happens is after 0.3 seconds, so I'm going to use k.wait, after 0.3 seconds, we will destroy the hitbox, because the animation is less than that, or approximately to that. So to destroy game object, you call the destroy function. And then here, I'm going to pass in the attack hitbox. That's why we needed a reference to it. And I'm also going to cancel the attack update ref. I call it a reference to, but you could have call it attack update listener. It gives you a listener, I think. Event controller. I should have called it controller instead. That was a missed opportunity. I should have also called this on-key release controller instead. Well, it's not too late. Let's do it. So I'm just going to call it controller. I'm going to also call it controller, just to be more precise. Not controller. Controller. This also is going to be called a controller. And finally, the last one is the ref. I'm going to call it controller. And I'm going to call it here controller dot, and then cancel that controller. All right, so now what we need to do is to create the logic to hurt the enemy. So we need to first know who is being hit. Is it the player? The ninja, or the samurai? To know this, we're going to create a enemy tag constant. And unfortunately, I haven't found a way to easily find the tag of a current game object or another game object. So really, your best bet is to probably just use the is function provided by Kaboom. You pass in a tag, and it tells you if that tag is indeed, if that game object indeed has that tag or not. So here, samurai, we want to check if this is a samurai. Actually, we want to check if the current fighter is the samurai, the one who hit the player, the enemy, sorry, is a samurai. If it's the case, that means the enemy is the ninja. Otherwise, it's the samurais that's the enemy. So just to reiterate, maybe I wasn't clear enough. We check the tag if the tag the fighter has, the current fighter that is attacking, has the tag samurai. If it's the case, that means the enemy has the tag ninja. Otherwise, that means the enemy has the tag samurai and the fighter was actually the ninja. And then finally, we have the attack hitbox reference. Okay, I see why I've put this last in my original code base, because we need this reference to create an event listener. So I'm going to keep it here. I'm going to create an onCollide event listener. So this is possible by Kaboom. It allows you to write this event to check when there is a collision with that hitbox that we just created. And then you pass in the tag you want to check collisions with. And the tag we're going to pass it is the enemy tag. And then the second param is just a function that is going to run when this case occurs, when this collision occurs. So what I do here, I'm going to simply do a k.wait, wait 0.1 second, and after 0.1 second, I'm going to run this function that is whole purpose is just to update the enemy HP, previous HP with the current HP. So enemy.previous HP equal enemy. Oh, how we get the enemy? Well, the onCollide function allows you to, when you specify the tag, to have the object, it will pass to the second function you pass to it, the object that has the tag here. So here, I'm going to call the HP function. So what does this do? And how do I do it? So the reason is I want to store the previous HP at a regular 0.1 interval after an attack. The reason for this is that if I were to update the enemy HP, previous HP property immediately, it's going to cause issues later on when we're going to have to work on the health bars, where we want the health to diminish gradually. So here the HP function method here is something offered by Kaboom once you use the health component on your game object. So every game object that uses the health component has access to A, the hurt function, B, the heal function, but also the HP function that gives you the current HP left of the player. All right, so now we're just going to have a simple if statement and call the HP again. So this is asynchronous. That means that it's not going to actually wait before moving on to the next thing. So I can actually, the code how it will behave is this is going to run. It's going to wait 0.1 second, but in the meantime, what comes after is going to run as well. If you want to make sure that this runs, so the program waits 0.1 seconds before proceeding on, you need to use await here. You need to use await and make this async, this function. But this is not needed, and we don't want that. So here we want to check that if the enemy HP is not equal to 0, so it's not equal to 0, we want to set the enemy health, hurt him by 1, reduce his health by 1. And we can do that by using the hurt function. All right, I think that's basically it. There's a couple of things left in that function. And that the if statement that was in the onKeyPress controller, it's basically the animations, all the stuff with the animations. So here, a simple if statement again. If the fighter, that the current animation is not equal to the attack, then we simply play the attack. That's it. Simple. Fighter.play. Whoops, the attack. Here we go. One line, and here we go. So that's basically it. And because this is also asynchronous, it's going to start running, but will still run. But anyway, if you really want to be safe and make sure that the box will have 0.3 second will be enough for the whole animation to finish before destroying the box, you can put it before. All right, I think we're done with this logic. Now we need to write a bunch of logics for when to display all of these animation properly. We need to hook into the update loop once again and really do a lot of stuff. So I'm trying to think maybe we should do this later. Okay, let's do it now. So right below, so just to collapse things, to make things clearer, initially we created this onKeyDown controller. We're done with that. We created the onKeyRelease controller. We're done with that. We're creating the onKeyPress controller, and we're done with that. What is left now is we want to hook into the update loop, so that you can do that by calling onUpdate and passing in a function. You can do that as many times as you want. everywhere you want. So that's something pretty handy to hook into the update loop. And here we're gonna have certain animations like the fall animation being played and really regulating which animation is allowed to keep playing, when to stop, etc. So even though we have made calls to play certain animations in our controllers, we still need to have some order in it, or otherwise you'll have animation conflicting with each other. And this logic took me a lot of time to have it work properly. So here, first if statement. We want to make sure that the character is not jumping. Is jumping is a method provided by Kaboom.js. What it allows you to do is simply, when the animation is running, not running, I mean when the player, sorry, I said, so is jumping is a function, a method provided by Kaboom.js. It allows you to check when the player is jumping, when a game object with a body tag is jumping. And by is jumping, it means not falling. So jumping doesn't mean the whole time where the player is not grounded. It actually means jumping. So when the player is ascending. So as soon as they stop ascending and start falling, is jumping is going to be false. And that's really handy because in the previous tutorial where I made a platformer, I wrote a lot of logic to deal with that case, to know when to play the fall animation. Here you have it done it for you automatically to know this. So just hook into, just call the is jumping function and check whether or not it's true. And it's going to be really easy. We also want to check though that the player is not, the fighter is not grounded. And of course we want to check two things. Wait a minute. So we want to check two things, two more conditions. We want to make sure that the fighter current animation is not falling already. Otherwise, there is no point in playing it. We're going to interrupt the animation and it's not going to look good. And we also want to make sure that the fighter is not attacking, because if they are attacking, we want to let the attack animation run its course rather than cancel it and play the fall animation. Because remember, I wanted the player to be able to attack while jumping as well. All right, I save this and the conditions should be all right. So now there's a bunch of other condition for idle, and actually there's only 3 other. So let's put the skeleton for those if statements. And after that, the only thing left is going to be dealing with the direction and what happens when the player is hurt, and dealing with when the player dies, and then of course the health bar. So that will be the last thing. In the second if statement, I'm gonna call the current animation. I just want to make sure that the current animation is falling. Sorry. So this is where we're gonna reset the animation to being idle after a fall, and we need to first know that whether or not the falling animation is currently playing, and whether or not the player is grounded. So if those two conditions are correct, are true, then we will simply do a fighter.play idle. Here I don't have to check that the idle animation is not already playing, because it will never. Because cur anim is, you can only play one animation at once. So it can hopefully never. But normally it shouldn't happen. And we return early. And the reason we're returning early is, is so that we won't waste any energy on that. And of course, I think we could have returned early here as well. And my prettier formatter is not working properly until I fix this squiggly line. So let's write a statement here for the last one. we're gonna check a bunch of conditions, and I'm not gonna copy them. I'm not gonna type them out. Let's just do this. Okay, what does this do? Why? So we want to check that the idle animation is not playing. We want to check that the jump animation is not playing. We want to make sure that the attack animation is not playing. We want to make sure that the hit animation is not played, and that the fall animation is not playing, and the run animation is not playing, and the fighter isn't dead to actually go back to the idle state. Now, can I improve this logic? Not sure. So let me think. We have the fighter. This describes when to fall. This describes when to go back to idle after a fall. Could I have combined those two? I think maybe fighter is grounded. Maybe if we check if the fighter is grounded as well. No, however, no, that's not gonna work, because in case of the player, so you could maybe add this as an or statement. Anyway, I don't want to deal with that. I think what I have is okay. Probably could be improved. If you have any ideas, feel free to share. I'm gonna just remove the brackets because it's the only thing left. And I think we have our logic done for this. Now the last part of this fighter.ts file is really to write the logic for when the player is hit. After having dealt with this logic, we will look at the output of the fighters, etc., the actual game, the state of the game, and then we will be ready to write the logic for the health bars. So what does happen in fighter on hurt? So here you have the on function, and one of the advantages of using the hurt function provided by Kaboom is that you have access to the hurt event. When this event happens, by using the on here, you can fire off a function that is going to run in that situation. Here the situation is perfect, because when the player is hurt is where we're going to actually play the hit animation when the player gets hit. And if you see here in the on update, I've put the hit animation here, but I haven't used it yet, so it's here that we're going to actually use it. So if the fighter fighter.hp, so this is how you get the HP, is superior to 0, that means we can play the animation hit, and we don't really need to deal with checking if the hit animation is not actually we actually need to do that. Yeah, we need to actually check if the animation is not currently being the animation being played is not the hit animation. So here I'm just gonna scroll up, write it out. Fighter.curAnim is not equal to hit. And then here we return early because we're gonna write some logic here. So the logic that we're gonna gonna write here is if fighter.currentAnim, so if the current animation is not equal to the death animation, so this is the only exception here, as you can see, that we haven't used, so it's not just the hit animation. So if the death animation is not the current animation, and here we go. So because this is there a reason maybe we should I just realized that this if statement might not be enough, because we're checking two things. Okay, we know that the hit animation will play, but there is a flaw here where we could have that the current animation is not the death animation. We could have that, but we could also have this, the HP not 0. Okay, it can never go. No, because the hit animation, just to be safe, I want to really guard this explicitly. So fighter.hp must be equal to 0 as well. So the player must actually be dead for us to run this logic. So here inside of it, fighter.isDead is going to be set to true. And one thing I just realized, I think you can get the current animation by just calling the property instead of the function. So, whoops, that would have saved us two characters, but anyway. Okay, fighter is dead. And then here we're going to cancel our controllers. So I'm just going to copy and paste. But now in the original code base, I used listeners instead of controllers. So I have to write controller. This is how we remove the ability to the dead player from moving. Otherwise, it will look weird. So on key press controller, on key release controller, and on key down controller. All right, now what is left is to actually play the death animation by using fighter.play function called the death animation. And then, knowing that the player is dead, we're going to actually need to display who's the winner and who's the loser. And to do something like that, I'm going to first need to get the enemy tag using the same logic we did earlier on. And then get the enemy object itself by passing the enemy tag, but you also need to pass in the recursive true. This object with the property recursive being true. The reason for this is that by default, the get function will not check for child of game objects. So that's why you need this. And keeping the checking for the 0th element, because get always returns you an array of game object, even if there is only one. So that's why you need to access the first index to get the enemy. Here is where we're going to add some UI things. So I'm going to go faster, I'm just going to copy and paste and explain it. Now those UI elements, usually I would want to put them into the UI folder and import them from there, but this doesn't seem really necessary. We're going to have an enemy status appearing on top of the enemy. It's a game object created directly as an independent game object because we need to be able to actually we could have put it as a child of the map. It doesn't matter at this point, but basically this game object contains a text component with the text winner. This is how you use the text component. You pass your string, and then you have optionally a second param, which is an object that contains options where you can set the font and the size. Here the size is 16. For the area, we're going to need that because we need to draw it from the center, and then we just pass in an empty positional component. The reason for this is because we're going to modify the position of those game objects only in an update loop, and we need to have at least even an empty position to be able to do so. So by default, I think if you just call position empty, it will just put the game object at position 0, 0 on the canvas. All right, so here as well, loser, so for the fighter status, so the enemy is winner in that case. In the case where the fighter has an HP of equals 0, 0 and has been hurt, the fighter is always the loser in that case. And here again, just the same thing to display text. And then within is not within, but right below, I'm going to write this code. So it's an update loop again. This time around, we take the enemy status game object, we put the position and update it by passing a vector to that is going to take the enemy position X, enemy position Y minus 40. The reason for that is so that the text is going to appear on top of the player. So that's right. And then here I left a comment in my original code base where I explained that when the fighter is the ninja and the fighter is dead, we want to position the status, the fighter status more differently than by default, because the way it works is that the ninja, when he dies, he falls to the ground head first. And if I were to keep the position the same I would for the samurai, for both fighters, then it would not, the text wouldn't appear to be like on the ninja. So that's okay, that's that. And then finally, the last bit we need is to call the get wait, not get wait, the k.wait, wait 5 seconds, and then just go k.go to the arena, which was the name of the scene. So we restart the game. So as soon as one of the fighter dies, then the game is over. So we display the winner and loser, etc. We play the death animation, we etc. We cancel the controls for that dead player, and then after 5 seconds has elapsed, we just go back to the arena, which is the same scene of the game, the combat, and then everything resets. So basically, it's like retrying the game. All right, I think that's enough. We have everything we need. There's one thing that I haven't written the code for yet, is the blinking. So when the character gets hit, we need to make them blink. But before doing all of that, let's just look at the result. So as you can see, the ninja is facing in the wrong direction. And of course, I forgot to add the call to add those controls. So I forgot one thing in main.ts. We need to, right after the cam scale and all that logic, we need to call the set controls. And actually, before that, you see set controls, I wrote it to do. We need to actually call set fighter controls, pass in the context, pass in the game object being the fighter, pass in the keys for that. So left, so this is for the ninja. So it's going to be left, the left key. For right, it's going to be the right key. For up, it's going to be the up key. For down, it's going to be the down key. This is the same logic we're going to use for the, so hit save, of course, go to the samurai, do the same thing, but instead of left right, it's going to be W A S D. And don't forget to also import that, and you should be good to go. And then here in main.ts, this is where you can just call the following. So call from entities, player one. You use this in case, because if you don't, it's going to tell you that because entity.player1 could possibly be null, because initially we set it to null and then we fill it in here and here, then set controls could possibly not be not defined. That's why in order to avoid this, you can use the question mark operator, which will only access what comes after if it's defined, basically, if set controls is defined. So that way you will avoid errors and stuff like that. All right, save this, and then can you move? I think I made a mistake with the controls. D shouldn't be the one for attacking. Okay, samurai, left, W, right, sorry. W is up, left is A, right is, not R, right is D, and down is S. So yeah, it's WASD, but in a different order. So you can see our ninja is facing this direction by default, and we're going to fix this, but just want to make sure that the hitbox are being drawn. You see? So now, for now, you can't really see the damage being dealt, but you can see that the ninjas can, the players can go through each other. You can see that they cannot go above the bounds of the arena. They can jump, they can attack while jumping, etc. And if you try to both hit, etc. All right, so we have something working. So we are at basically the last part. We need two things: blinking and health bars. So let's start with blinking. By blinking, I mean like making the characters blink when they get hit. And here we're just going to write a function within the fighter.ts because it's shared logic, really. and export that. We don't actually need to export it because it's going to be used within this file. So I'm going to create a function and I'm going to call it, I think I called it set, never mind, not set, make fighter blink. And you know what? Just to go faster, I'm just going to copy and paste it and explain each line. There's no new concepts really. Oh, actually there is if you haven't watched my previous tutorials. So here it is. So this is a function I created. I called it make fighter blink. It takes in the Kaboom context, of course, to have access to all Kaboom functions and stuff like that. And also it takes the fighter as the game object of the fighter. And here, this is where it needs to be an async function. And the reason for that, and it's also the reason why we have the opacity, the reason we use the opacity component previously, is that to make the character blink, what I do is I use tween. So tweening is basically gradually changing a value from one value to another following an easing function. And the way to achieve the blinking effect is to first tween from the current fighter opacity to 0 in 0.5 seconds. So this is how it works. So the tween function takes the initial value, the resulting value you want at the end, and how much time you want it to do for it to be done, and the function the function to update this value. So here fighter.opacity equal to the new opacity. This opacity is passed every time as the easing progress, and the type of easing function you want to use. So here linear. So the value will vary linearly. So gradually like that, following a linear function. And the reason I'm using await here is because I do not want to do the second tween until the first tween is finished. So first we go from full opacity to 0, so the character will disappear for a brief moment for 0.5 seconds. And then once this easing is done, we do the second one. And the second one, here you don't actually need to have the await a second time. You just need to guard the first one. I think you don't need it. But basically, in the case you plan to write some more logic right here that needs to occur after the blinking is done, then you would need it to have for both of them. So just, I'm going to keep it for now, but it's not necessary, I think. Here, so in the second tween, we take again the fighter opacity, but now it should be equal to 0 because of the previous tween has completed. And this is all because of the await keyword, because the tween function by default, by itself, could, if you would call it without the await here and here, run asynchronously. So while you call this, it runs, you call this, it runs, and the rest of the program is executed while the tweening is ongoing. But if you want to have things in a linear fashion, sequentially, then having an await is really a good way to achieve that, because it will await. This function will not move on to what comes after it until the tweening is done here. Same thing here. So the tweening here is not going, the function is not going to move on with code execution until the await is done here. Here it's not that necessary because, remember, there's no code after it that we really need to guard, so you could remove it. All right. So here we take the fighter opacity, which should be equals to 0, and we want to put it back to 1 because the opacity varies between 0 and 1 in Kaboom.js. And same thing in 0.05 seconds and following a linear function easing. So that's how you use it. So 4, 1, 2, 3, 4, 5 params that the tween function from Kaboom takes. All right, so we have created this. I'm going to save it. And I'm going to now go to the hurt here. And I think it was right when the player is hurt, you just call this function. So make fighter blink. You don't need to use await outside. The reason you don't need to use await outside here is simply because we don't really care whether or not we execute this at the same time with this. It doesn't matter. So because of this, it doesn't matter. I might as well just remove it. Remove the second one because it's not needed. So it's really only the first await that we need to make sure that once this tween happens, then the first tween has already completed. All right, hope I was clear. Now let's look at the result. So just making sure that, yeah, make fighter blink, everything is fine. So let's make sure that everything works. Oops, that's the final game. Now, if I hit, yeah, things seems to be working. That's great. So now what we're going to do is we're going to work on the health bar. And before doing that, let's set the direction of the ninja to being, like, let's set the actual directions. So here for the game object, so the ninja, the direction is going to be, I'm going to take my enum here and make it right, left. So the ninja must look to the left. Why is this an issue? Directions.left is not assignable to the type null. Okay, that means we need typing. And for typing, wait a minute. Wait a minute. You know what? To avoid having to do extra typing here, while it would be beneficial, what I'm going to do is I'm going to go back to the fighter.ts, and here initially I'm just going to remove it from the fighter props, and I'm going to go to the ninja, and here I'm just going to put it within the brackets here, so I don't have to do the typing manually. And of course dot here, so that it can never actually be null. Is it going to not cause an issue? I don't think there's any place where we set it to null. So let's do this for the samurai as well. I'm gonna have the direction, and here called the enum right. All right. Okay, that didn't work. Oh, I think I might have not done it correctly. That's for the attack. Let me just look it up what I did. So why is the ninja not facing? For the ninja specifically, we need to initially face it left. So it didn't matter really that you put the direction left or right. Doesn't hurt. And will avoid us from typing the fighter props, which isn't a good thing to say necessarily, because it's useful to type stuff, but just do not take much more time. So here I'm gonna flip to true the ninja as I'm creating the game object, so that when the game starts, he looks to this side. He looks to the left, sorry, because by default they look to the right. But the direction from where the attack, so let me check if the attack works. Yep. And then, yep, it works. All right. All right, so the last part of this tutorial is the health bar. By the way, if you have enjoyed the content so far, feel free to subscribe if you want more. Yeah, it would help support the channel, and that would be great. And now for the health bar, and also leaving a like if at all possible. I think it's might have an impact on the algorithm. I'm not sure though. In the UI folder, you have this health bar.ts file. And what we're going to do is we're going to create a function. So I'm just going to clear things out here. Export function make health bar. That will be the name. As for the params, we're going to need three things. As always, we need the context. So Kaboom.ctx. We also need the direction. So this you can just call the enum here, even though it's a specific direction. And then the owner of that health bar, which is going to be a game object. And then here, I'm just going to click on the light bulb, add all missing imports. Now, for the positioning of those containers, of the health container, the health bar itself, I'm going to create a const. I'm going to call it health container position, and it's going to be an object, and it's going to have two keys. And like with the previous case, we'll have to type this out. So I'm just gonna have to do it right now so I don't forget. So a key of type string, and the value, it's a vector2 of the type vector2, provided by Kaboom.js. Here we go. The import has been updated. And now for the left key, the value that makes sense, that will put the health bar to the left corner of the screen, is this coordinates. The way I have figured that out is through experimentation and trying values. Do the same if you want to really understand. As for the health, yeah, so that's that. Now we're going to create the health container itself. Health container. And here I'm just going to copy and paste and go over each component that is being used. So health container is going to be a rectangle of the width of 600 pixels by a height of 50 pixels. It's going to be of a green color, not of a red color. So basically it's what is below the health bar basically. So as the health bar, the health display, I guess, is reducing, which is the rectangle, the green, I think it's green. I don't remember. Yeah, it's green. As the green rectangle is reducing, then it exposes the health container, which is going to be just a red rectangle. Red because we use the color component here. It's RGB, red, green, blue. They vary from 0 to 255 for each of those. Here we have the area component. We have the anchor component to center that health bar. Here, Kaboom allows you to have an outline over your rectangles. So a thickness of 4. This is offered by Kaboom. For the position, we get the position by using this and checking whatever the direction being passed is left or right. So that's how we can provide this to the positional component or that, depending on the situation. And of course, fixed. This is important because we don't want the health bar to be affected by the camera, even though in this game the camera doesn't move at all. All right, the second game object we're going to need though is the health display, which is the green bar. It could have been named better, but basically it's a child of the health container and it's going to be placed on top of it. And the order of things, how things are drawn, is basically the last thing drawn is drawn on top. That's why the health display is going to be above the health container, even though like it's a child of that. And here again, it's a rectangle with a slightly smaller width so that we can still see the outline, etc. The color is going to be green because R for red, G for green, B for blue. And then the position is this position. This position is relative to the parent. So it's minus 300 pixels according to the parent. So this is again a value that is hard-coded that I found to be great. I use the rotate component and rotate by 0. This is going to be useful. For example, if for the right health bar, we're going to need to rotate it 180 degrees because the way the health bar reduces is from opposite directions. So for example, if I show you the finished game, here, if I hit, the bar was slowly reducing from right to left. If it's the samurai that hits, it's the reverse. That's why we need to rotate. Now that this is done, I'm going to have an if statement right below. And here, if the direction is right, we're going to rotate by. That's possible to use this method because we use the rotate component when creating the game object for health display. And we rotate it by 180 degrees. And then the position of the health display, so the green bar, also needs to be adjusted just by removing the negative signs. And then finally, we have this last function. I'm just again going to copy and paste and go over each line. So here, we hook into the update loop again. This time around, we need an async function because we're going to use tweens again. Actually, we don't need it. I just realized it, so remove it. It's not necessary. That's something I forgot. Yeah, sometimes I add stuff like that because I used a weight and then I removed it, but I forgot to remove the async because it's no longer needed. So here it's where the owner, we check if the owner HP is equal to the owner previous HP. If that's the case, then we don't reduce the health bar. We wait. And that's why earlier on we were modifying so that when the players get hit, there's this delay between the owner HP being equal to the owner previous HP so that we can have a gradual smoothening, like a gradual progression of the health bar. Otherwise, if it were really in sync, because we were hooking up into the on update loop, you wouldn't see anything happen. Anything like the health bar would reduce instantly instead of having a small delay and then gradually getting smaller like in multiple games. And if you increase the time here from 0.1 to maybe 2 seconds, it's going to be like more like in Dark Souls game where you see when you play those games, you get hit. Well, there is a delay between the damage it took and the health bar. So there is this delay where the health bar gradually goes down. All right, so here, after in the case where the owner HP is equal to the owner previous HP, so the owner is basically the game object, the fighter, then we just skip this iteration of the loop. Remember, it runs 60 times per second, so every frame, it's written in here. And that's one of the great things of using npm, etc., is that you have like documentation here that you don't have if you use simply a normal vanilla JavaScript modules, etc., without using npm or the Node ecosystem. All right, so you have owner.previous HP equal owner.hp. So that's after if this is not the case, then we make it the case so that next time it's going to be the syncing is going to so that we don't going to go over and update too much the health bar. By putting it to being equal, this will guard it and prevent some of the time from the loop of some of the time it's going to prevent the loop from occurring. Sorry, it's a bit hard to explain. And then we have an if statement. If the owner's HP is not equal to 0, then we tween. And the way we're going to do this is we have this reduced with by constant that basically divides the width of the green bar, which help display that width, you can get the width like that, by the maximum HP of the fighter. This is done once, basically. It's going to give you how many hits take from the health bar, the visual health bar. In the previous tutorial when I did this, it was different. It was more, I just had a one-to-one relationship between the health bar and the actual health of the player. So I did not have this decoupling. And working on a bigger game, let's say you want to really make a good fighting game, then you would have to decouple that to make sure that the health that is displayed is not the exact, like the player doesn't die when the rectangle reduces. So for example, you could have two characters, one with more health than another. Maybe not in a fighting game, or in a Pokemon game where the health bar is the same size, but the Pokemons have different HPs. Okay, so here, tweening, same thing. We go from the initial width to the width minus the reduced width by constant after a hit in 0.1 seconds using linear, and this is how we set the new width every time it gradually changes. And then we return early so that we don't do this. So in a case where the HP is equal to 0, we don't bother. We will just make the health display width vary from its current width to 0 in 0.1 second, like this. And the reason I'm doing that is simply because there are cases where the player still spams the attack to the point where the player is already dead, the other one, and the health bar hasn't finished reducing. So just to avoid having a glitch where the health bar would not be fully depleted, but the enemy would be dead, then this comes in handy where you just put it to 0 if you know for sure that the HP is equal to 0. There's one thing that is left that I forgot to include, is that in the main.ts file, right after here, you need to add the following for it to actually work, for it to actually like use the health bar. So I'm just gonna try it out here. I'm just gonna copy and paste it and then again cover it as I usually do. Just remove the extra bracket. And of course I need to import quick fix, make health bar. Okay, well, I need to import the did I export it? Make health bar, import it in your file, import make health bar, and for some reason, what's the issue? Cannot find make health bar. Did I write it correctly? Oh, I used a capital B instead of a lowercase b. So yeah, can use either way, it doesn't matter. Oops. In the origin, I think lowercase to be like to fit with my code base, my original code base. Let's use the lowercase and let's go to health bar. All right. Now that this is done, things should be working. Whoops. Saved. Now let's test the game out. So I'm gonna play with the ninja, try to deplete the life of the samurai. And then I can jump around. Winner, loser, etc. And then the game restarts. Let's see what happens with the ninja when the ninja dies. And yeah, he's the winner. And you can see, all right, the game works. Hope you enjoyed this tutorial. Feel free to subscribe if you would like more TypeScript content or JavaScript game dev content as well. And see you hopefully in the next tutorial or video. Bye. If you want to export the project to itch.io or some other like website, the way to do that when having a setup like this is, I'm just gonna stop the game. In the terminal, you can stop by using Control-C, is you run npm run build. Then once you do this, it's going to compile your code into a bundle that is going to be under the dist folder. And then in the dist folder, you have your assets, everything. You go to your index.html file. If you don't want to play with Vite configurations, you just add a dot here. A dot to have your assets load properly. And then once you do that, just create a zip file that contains all these files, these 4 files, and then under a zip file, and then upload that to the itch, and it should work. All right, so yeah, I forgot to tell you how to do that. And so if I want to test that out, I can use Open with Live Server, which is an extension that just creates a server under an HTML file. And then you have your server and you can play your game. All right, thanks for watching. Bye.